everybody. So, welcome back to the web and mobile track. So I hope everybody enjoyed the first sessions. We will not have, we always have better sessions all the way. So we have very good speakers today. So for the first talk today, we have one of the Angular JDEs, Thomas. He's a great father, I would say, with having the maintainer for Angular challenges. I think all the people who works with Angular knows this challenge is very good. It's really interesting. So people, please try it out. Thomas, welcome to the stage. So please start.
Thank you. Hello, everybody. So let's start right away because we're a bit late on schedule. But the first talk of this TIL Conf will be about TanStack query, and I will introduce you this amazing library that was very recently adapted to React to Angular. Oops, I need to. Up. Yep. So the library was created in 2019 by these two remarkable developers, Stanley and Dominic, and was first developed for the React community. But last year, Angular introduces signals into the framework, and Arnaud, which was previously a React developer and who came to the Angular world, decided that these features were missing and created the adapter for TanStack query. So before going further, so let's present myself. I'm Thomas Laforge. I'm a front-end engineer in France. I currently work at Rosa. It's a healthcare company based in Belgium. I'm a Google developer expert in Angular. And I think many of you, or most of you knows me because I post regularly about Angular challenges. So for those who don't know these challenges, is a GitHub repository like this. So you can have the website, which gathered currently 51 challenges around Angular. So you just have to pick one, and then you can resolve it, push it on GitHub, and someone from the community can review it. So it's a very good way to share best practices and to learn alongside each other. So if you haven't tried it, I invite you to try them. And if you want to reach out to me or to follow me, you can do it on X or LinkedIn. I'm very active on those two platforms. So let's start. So TanStack, what is TanStack? TanStack is a data fetching library. So the first advantage of TanStack is it is an opinionated library. It means that it comes with a predefined and robust way of handling asynchronous events. So it's like Angular. When you come from one project to another, you will find the same data structure, and you can start develop very fast because you know already how Angular project looks like. It's the same with TanStack. You will not have to come with your own implementation when you will handle asynchronous events. The main objective of TanStack is to manage asynchronous events. And we all know that in Angular or front-end application, the main asynchronous events are HTTP requests. So TanStack is very good at handling the server state, as we can call it. So the server state is everything that is coming from a remote location that you don't own, meaning that when you get the data from the server, the data can already be outdated. So most well-known state management libraries like NGRX, Rx Angular, or other libraries are very good at client state management. It means everything that is, or the state that is stored inside your client application. For instance, if you have a checkbox, you check it and you want to store the state of that checkbox. If you have a theme switcher, you want to save the state of the theme the user has saved. But those libraries are not very good at everything that is asynchronous. And on the other hand, TanStack is not good at all at client state. Well, it's not a client state management library. But if you combine both libraries, it is a very good match. But you will see later on in the live demo that almost all the state inside your application will be hidden with TanStack, and you will almost have no more state left. So you can only use like basic signals. Since TanStack is very good at server state management, is also very good at server state synchronization. It means it will know when to update data, and it will update them in the background when it is outdated. It will memorize results to avoid overfetching. And for instance, it will also manage useless, unused data, and it will delete them from the memory to save some memory. And you will find other features in the documentation if you like. One other thing that TanStack brings is automatic caching. So we all know that caching is a very hard thing to do in programming, and TanStack do it for you. You just have to add TanStack to your database, and you will be able to cache your HTTP request. And last thing I want to highlight is the library is suspense ready. It means it will come with an error state and loading state out of the box. So you don't have to write is loading, is error everywhere inside your application. So if you have already implemented all those features, it's very good, but most of us, me included, haven't. And TanStack will give you that right out of the box with no configuration needed, almost, and in an incredible, straightforward way. So let's see how we can install TanStack and how it works. So the first thing you need to do is to install those two libraries. The first one is the main package. So as you can see, it's still in an experimental stage. It's because it's very new, and the team prefer to remain cautious and to just leave it experimental right now. And the second library is the dev tool. You will see in the live demo that the dev tool is very powerful and very handy. To install TanStack, the only thing you need to do is to provide a query client inside your root configuration. The query client is the central piece of TanStack and is everything that is managing the cache. So the first API is inject query. TanStack is built around the concept of queries. A query is a wrapper around an asynchronous value, and it will provide you a declarative way of handling that data. The inject query is everything that is getting data from the server. So you need two mandatory parameters. The first one is the unique key. So it will be useful for caching, refetching, and sharing the data. The second parameter is the query function. So the query function must return a promise. And as you can see, it's backend agnostic. So in Angular, you will use HTTP client, but you can use fetch or Axios in the same way. The result will be an object of signals. You will get the data returned from the query function, and you will also get a bunch of status like error, loading, fetching, success for the inject query. The difference between loading and fetching is the loading state is when you don't have any data on your query yet, and the fetching state is when you already have data. So TanStack will display the data on the client, but will fetch in the backend. So it can be useful to show to your user that you're fetching in the backend and that the data on the front might not be updated yet. So if we look at the query key a bit more closer, it must be an array. It can be as simple as a simple string or as complex as using multiple strings, variables, or objects. The order inside the array is very important. as we will see later. And one thing to remember is when you're using a variable inside your query function, you need to duplicate it or to include it, I mean, to your query key. So it's very easy to understand. Since the data returned from the query function will be stored behind the key, if you're fetching for two different users, for instance, user 1 and user 2, you want to store them behind different keys. The second API is inject mutation. So this one is used for everything that is mutating the state, like create, update, or delete. This query only needs one mutation function, and it must return a promise as well. It also includes some side effects that are very handy, like unsuccess, on error, and unsettled, depending on the result of the promise. For instance, on success, inside this hook, we can invalidate another query. Invalidating a query means when we will need to fetch the data stored behind the key of that query, we will need to refetch the backend because we are telling the cache that this data is not fresh or need to be updated. The last thing I want to show you before going to a live coding session is how to include the dev tool inside your application. You only need one line of code and you will have a very powerful dev tool with you if you include this line on your root component. So let's do a demo. So for the demo, I have created a very basic application. If you click on it, you will fetch a list of users. So you can click on one user to get the detail of that user. You can edit the user, or you can add new users. Here on the bottom, we have the dev tool of TanStack. So it's when we are adding the dev tool, we have this line. It's only available on dev mode, of course. And for now, we don't have any queries because the application is using the basic HTTP client only without any TanStack on top. And those two other buttons, it's just to go back and forth to see how the cache is working. So now let's jump into the code. The first component we have is the user component. Inside this component, we will fetch for the user when we initialize the component. So we will set the loading flag to true, fetch the user, and then if we have an error, we will display an error. And if the request is successful, we will update the user signals and the loading signals as well. So now we can, on our view, on our template, if we are loading, we will show a loading state. If it's an error, we will show an error state. And if we have a list of users, we will display all the users. So now let's implement and add TanStack. So for this, I will need the user service, and I will create a user's query. So for that, we will need the inject query API, which is returning an object. For returning object. So the first mandatory parameter is the query key. For that, the first element as a convention should be the domain on which we are working. So here it's users. And then I like to be a bit more precise on what I'm looking for. So I will use the keyword list because I'm fetching for the list of users. The second API is the second parameters is the query function. So since HTTP client is returning an observable, we need to wrap it inside last value from to transform the observable to a promise. And user service get all users. Nice. So as a naming convention, I like to add query after users because I'm not returning the list of users, but I'm returning an object containing the list of users and also a lot of other flags. Now we can delete user store. We don't need that anymore. We don't need this anymore as well. And we can replace in our template all values. So now we're not returning users, but datas. I will add just on top another flag, which is fetching, fetch in the background. When we will fetch new data, but we will still display data on top of our application. So now if we come back to our list, we can see that now we have a query. We have made a query, so inside the dev tool, we can see that there is a query appearing. There is a lot of very useful information. Fresh will give you that if the data is fresh, meaning if we need the data again, we will not fetch the backend again. Fetching, it means it is fetching in the backend. Pause, the query is paused. Still, it means that if I go back and I come back, we will fetch the data again. And inactive, it means that we are on another like tabs or view, and this data is not displayed on the screen and is not active anymore. As a default configuration, stale is set to 0 minutes. It is very aggressive, but this way you will always have fresh data. We can, of course, override this configuration to fit our needs a bit better. For the purpose of this demonstration, I will put 5 seconds. Now, if I come back to my application, we can see that for 5 seconds, the list of user is fresh. So up, we can see that we are doing one HTTP. If I'm fast enough, we can see that we are not doing any more requests because we will hit the cache first. Now let's do a bit more complex implementation with user details. So user details is when you click on one user and you will get to the list of users. So for this, I will need as well the user service where all my APIs is located. I will get the user ID from the URL using the new input syntax and with the URL bindings. So if we use user ID inside our URL, you will get it inside this input. Very handy. And we will create our user detail query. So same thing as before, since we are getting data from the server, we will use inject query. Now, of course, you can get the details from the cache if you want, because we have the same data. But for instance, for the list, in some application, you will only load like the name and the age. And when you get the details, you will load a lot more information. So that's why I'm doing separate queries, and just to demonstrate how we can query it. So same as before, we have to use query key. We are inside the domain users, and this time we are getting the details of this user. We have a function, which is returning a promise as well, and we will get from the user service the details. This time, we need the user ID, so we get it as an observable. One other thing to notice with TanStack, we can use observable directly, we can use signals directly on observables, and it will re-trigger the observable when the signals is changing. If you want to do it using two observable and two signal of Angular, it's a bit more complex, because if you're using a signals inside an observables, it will not re-trigger the observable when the signal change. You need to do 2 observables of the signals to transform into an observable, merge map it to get the HTTP request, and then retransform it to 2 signals to display it on the template. So it's not a very nice syntax, and this way it's way nicer. So one thing you need to not forget is to hide this variable inside the query key. Now, same as before, we can delete all of those code that we don't need anymore. Here we replace everything, and to display the data, we use data. Here we are calling the data twice, but since it's a signal, it will not do 2 change detection cycles. It will only do 1, and the data will be called only once because it's not an observable. It will not re-trigger the observable. So we can do it like we don't have to do like @if and create a scope variable. So now if I go back to my application, we can see that now we have a new query that is created. If we want, we can override our settings per query. So for instance, for this one, I know that the data will never change, so I can put the style time to infinity. This time I will only fetch the backend once, and that's all. But for the purpose of this demonstration, I will put 10 seconds, for instance. There is also another option that is very useful, is garbage collection time. The garbage collection time, it's when the data is unused, you will clean the memory from this query. So if I'm coming here, we can see that we have 2 queries of details, and one disappear because after 11 seconds of being unused, it will be cleaned by the garbage collection time. Okay. Now let's move to the new section, which is inject mutation. So for that, I have a pop-up, a dialog, that will create a new user or will update a new user. So this is the same dialog. The only difference is when I'm giving a user as an input, I will be in edition mode, and if I don't, I will be in creation mode. So the first thing I will do is user create a query. This time I will use the use mutation function, and inside it I only need to put the mutation function parameter. So I will need to uncomment this line, import it, and then I can call the create user. So I need a user as a parameter, which is of type user create, and I need to pass that user. Great. So now we can replace this line with our query. To call it, we call user create query. Then inside it, we call the mutate function, and we pass our new user. Great. Now with this mutation function, we have a bunch of status we can use. So for instance, to show a small loading indicator, we can call the isPending flag. And when the query is in success, we can call the isSuccess flag. This way, when the user query comes back and is successful, we will reset the form and close the form. So now, if we add a new user, I will clean the dev tool. If we add a new user, Bob, we can see that the request has been made, is successful. We can go here, mutation. We can see it is successful, but the list is not refreshing. We don't have our Bob user here. Why? It's because we didn't leave the page and we didn't tell our query to refetch the data from the backend. So just before fixing this issue, I will show you what is happening when we leave, because this query is invalidated. So next time we will need this data, we will refetch in the backend. So if I go back to dashboard and I come back to basic, we see that it's fetching in the background. And now we have our new user. The old data were displayed, and now the new data are here. But it's not very good to do it like this, so we will use on success. And when the data comes back, we will need the client, because we need to work on the cache. And now we will invalidate the query key, and we will tell users. So before, in the slides, I told you that the order inside the query key matters. It's because if I'm only using users now, all the query starting with users will be invalidated, meaning the user list will be invalidated, but also user details and all the user details. It's not what I want, so I will put list here, but it can be very handy. And if you want only users, you can use the exact flag just behind, and it will only invalidate users. So now if I refresh my page, we'll put it back to no routine. We can, oops, what's happening? No routine, okay. We can now, George, add a new user, and he will refetch this query. Great. Just before jumping to the next thing I want to show you, I forgot that we can click on one query, and there is a lot of actions that you can do. You can click on refetch, invalidate, reset, and remove if you want, but you can also trigger loading and error state manually, which is very good because you don't have to trick or to change your code to test the loading screen or the error screen. If we click on it, we can see that. And if we click on error, we can see the error screen. This can be very useful when you are working on this screen. So since I'm a bit running out of time, I will go a bit faster. Oops. So I want to show the terminal, reset all my changes, and I will go to this. So here I just implemented really fast the update query to update a user. So this time we will invalidate the list, but also we will invalidate the detail of one user. There is also another option. You can, if you don't want to invalidate a query which is making a HTTP request, you can directly work on the cache by calling, like, for instance, set query data. You give it the key you want to work on, and you can change directly the data behind that key. So you avoiding one fetch. But the best practice is to invalidate the query to refetch the backend, because this way you will get the fresh data as possible. So one thing I want to show you also as best practices is like what you do when you create like a service, HTTP service. You will locate all the code related to the user inside the same user service, for instance. We can do the same with the queries. So if I check out here and I open my tree, we can see that now we have a user service, a user query file. Inside this file, we have all the queries related to the user. So it's using the new inject function. So we are just making a small guard to avoid people to call inject user query outside a user context, an injection context. And then this way we can use inject user query anywhere inside our application, and it will return the list of users without with fetching or not refetching the database depending on the query key status. And one last best practice I can show you is, oops, what happened? We can create a user key factory, which will have all our keys. And this way, when we call them, we will not make any typos, like forgetting a S or something like that, because we will using the user key factory for storing our data or for invalidating our data. So I hope you enjoyed this talk, and now you can go to your project in your company or side project and implement TanStack query on the already existing project. It's very easy to migrate. Thanks a lot for listening, and enjoy the rest of the conference.
Thank you very much, Thomas. So very interesting talk. Can't wait to try it out. So this is the first thing I will do after the conference. So yeah, thank you very much. And now for the next talk. Yeah, our next talk will be Chai. Be talking to us about how to optimize the enterprise grade web performance. Yeah, this would be interesting. So Atishai is engineering manager at Birdeye, and he's passionate about web development, like I think everybody here. So he has 9 years of experiences to develop like scalable web products, and he's always enjoying researching new technologies. So yeah, give it up to Atichai. We can start now.
Yeah, thanks, Ahmad.
Let
Let me present my screen. You are able to see my screen?
Yes, I think everybody should be.
Yeah. All right. Hi, everyone, and thanks for opting in to listen my talk. So I'll be talking on the stuffs related to web performance and specifically why it matters when we talk about enterprise grade web performance. And to start with, I would like to give a brief intro on like what is the meaning when we say that it is enterprise grade, because when we talk about a backend system versus a front end system, the definition of scale for an enterprise is a lot different. For a backend system, it could be related to the number of traffic which a server is experiencing, or the number of resources which are available for the server, or it could be related to how many data the server is processing. But when it comes to a web driven front end environment, it is a lot different. And so we need to see that what exactly we mean when we say that it is an enterprise grade front end code, and why does uh, the front end code would fall apart if we don't follow some of the standard practices or some of the tools which we all are aware of. But what we tend to do is we tend to introduce such kind of tools very later in our dev cycle, and as a side effect of which, what happens is our development time gets slow, our performance deteriorates, and we get into a number of problems. So before I go a little deep, I will like to introduce myself. So myself, Atisha, I currently work as an engineering manager with Birdeye. I had been working with Birdeye for around 6 years now. I had developed a lot of web applications for them based out of React, Node, and all the like ecosystem around it. So currently, I'm fortunate enough to lead a team of good uh, engineers who are working on various web technologies, whether it is like performance oriented, whether it is Node and like that. So I'll be more than happy if you follow me on Twitter or LinkedIn. My handle is by my complete name is Atish Abad. That is same on LinkedIn and Twitter. You can find me there. I'll be more than happy to connect. So in this talk, like, we will start with looking into that why performance is improvement is important, why in this era businesses can't live without performance, and what it is impacting to all the business matrices. Then once we understand performance, we will see that what are the measurement techniques, because till the time we cannot monitor anything, we won't be able to improve it, and we won't be able to tell the users that what exactly is happening. And then we will see all these tools, and then we will see that how we can utilize web vitals along with some of the real user insights to improve the performance. So now, as I was talking about enterprise grade web performance, we will see that what are the hard parts when it comes to front end development. Uh, the front end development could be hard because there are limited browser resources. Because from my experience, I can tell you, I was developing a chatting application, and what happens was, when the concurrent messages start increasing from a given threshold, because the browser is single threaded, it has a limited amount of memory. The browser would start to lag, because let's say you are receiving close to 80-90 messages per second, and your JavaScript is constantly involved in processing those events. So the main thread is always busy in getting the message and rendering it to the UI, whether whatever framework it is, like Angular, Vanilla JS, or React. The other common set of problem which would uh, appear, because on the web we have started to support lot many data. So there are large number of arrays or large numbers of backend data set which we support on which we render on web, and as a replication of which, the performance over the time starts to degrade. And also with the rise of the modern frameworks, let's say React or Angular, what is happening is we have started to support n number of functionalities on the browser, and the rendering pattern for most of these frameworks are not very straightforward. So let's say if I take the example of React, there is server side rendering, there is client side rendering, and always there is a trade off, and that's where engineers confuse in between that, for this functionality, that what is the correct approach I should take, or should I go about prioritizing some stuff, and should I go about deprioritizing some stuff, and that's where some of the performance problem appear. And also what happens is, since everything is related to business, we are at the end developing the web for the business problem. So constantly in the when you are developing the products, you have to support lot many functionalities. If you compare a website which was like 10 years back versus a web development now, you would feel that we have started to support lot many functionalities in the browser, and as a result of which all these problems are getting relevant. Yeah. So why these problems are relevant now? So why in the era of PHP, or in the era of when the server technologies were very popular, why these problems were not very relevant? So what has changed in the web is, if you compare MPA with the SPA, which is now, uh, everything was happening on the server. Only the client or the browser was only responsible for the development of or showing the feedback to the user, the processing of the HTML, or getting the data, or the routing, or the mutation, or the rendering would happen on the server. The server would generate the generate the HTML and throw to the browser. But now, uh, because we wanted a web which is convenient for the developers to develop, and it is it is more user experience friendly, what we started to do, we have taken most of that uh, part to the client side. And as a result of which, on addition to giving the feedback or rendering the page, uh, our front end is doing the work of routing, we are doing the work of data fetching, we are doing the work of mutations, we are doing the work of rendering, and which traditionally were related to server. But now, since we are supporting all these things, the browser or the nature of JavaScript, the implementation of JavaScript which is available in the browser is a single threaded, and which results in lot many performance problems, and that's why we need to take care of all these performance problems from the very beginning. Yeah. So if we see a average website site, this data I got from the Internet Archives, the amount of network with the bandwidth, or the amount of uh, or the amount of data which is getting transmitted over the network has really gone many folds, and the size of web has increased a lot, and as a result of which the performance or all these issues are becoming very relevant. Yeah. But why should we like care about the performance? Is it like from the day one should I care about the performance, or how should I convince my engineering team or the business team that yes, we this is the time we need to improve the performance of the web, or we need to have a monitoring system in which we can have a better performance. So first and foremost is the user experience, because uh, now let's assume there are two websites, one website which is taking like, let's say, 10 seconds to load, and there is the other website which is getting loaded in the couple of seconds, and user is able to perform all these tasks seamlessly. So even if the second website is charging the user more money, or more in terms of the premium, but the user would prefer a site which is more experience oriented, and he would like go about doing this stuff. Now the second part would be, let's say you are developing a B2B application, or you are using some kind of a crm tool. Now if the tool is not performant, the time of the people who are using this tool would impact a lot, and it would eventually lead into the degrade in the productivity of the people who are working on the tool, and eventually this will lead to uh, a downgrade for the complete business. Now I recorded a video to show you how a normal thing can be really slow. So let's say there is a guy who is coming onto this website, and now he's trying to like apply some locations, he's trying to play around with it, but see this experience is creating a bit of the jank, and that's where we need to improve it. Now as I talked earlier, the experience would degrade, the productivity would degrade, and it will also lead in to eventually downfall in the revenue. So there are relevant data available in the uh, internet that shows that if the website is performance is down by a couple of seconds, you would lose a lot in the revenue. And if we talk about, let's say let's say you are watching Netflix on the web, or you are uh, Hotstar or any of the streaming service. uh, so what would happen is, if to load a web series, if it is like taking a lot time, or the experience on that frame the platform is not good, you would leave that platform, and it would eventually lead into the degrade in productivity and revenue. Also performance would also Google or all the SEO engines, uh, they would impact they would only rank the website which loads very fast on their servers, because they also want that people who are coming to that search engines, and let's say they are searching for a keyword, and now the website is available. They want that the experience should be really good, and that's why it impacts SEO. And the second reason would be because to like crawl a website, any search engine or any of the bot would need to render your page on the server. If it is taking a lot time to render the page, or if the experience, or let's say he's clicking on the buttons and the buttons are lagging, the bot would not be able to get through all the content. And if it is not being able to get all the content, what will eventually happen? Your website rank would really affect, because all the content has not been passed by the bot. Yeah. Now the performance, or it would also impact the time which user spend on the website, because if the experience is not very smooth, the people would tend to bounce from the website. They would jump from the website really soon. They would feel frustrated that, hey boss, what is happening? I'm not able to see the products, or I'm not able to perform my desired task. And the downfall in the session timing would eventually again relate to the point 3, which is revenue and profitability. Yeah. So now, since we know that performance is something which is really important, and which is something we need to focus from the day one, but how do we measure it? Because without measuring it, how would anyone know that uh, this page is really slow, or we need to optimize it? So there are several tools or techniques which are popular. I will be talking on like a few of them to cover that how we can utilize these tools to make sure these that we measure correctly. And by all the, let's say, the developers are developing the code, so with every PR or with every new release, you need to have some kind of automation system in place which would like check through your web performance. And you also need some systems in place which are like looking which are eye uh, for the end user. So because the end user could use n number of devices, he could be on a limited resources phone, or he could be using a very old Windows machine. And that's how you will be able to see that, yes, my experience was good on a high end Mac, but it is very slow on a Windows machine. And because my majority of the customers are using a Windows machine, so they are feeling frustrated, and that's why it may impact my revenue as well. And that's how I should start to optimize it. Now, the first and foremost thing to measure any performance system is Web Vitals. So Web Vitals, you can relate it to. Let's say you go to a doctor. You are, let's say, having a fever, or let's say you are having some kind of infection. What would a doctor tell you? He would tell you to get your. Firstly, he will say that show me the vitals. So vitals are something which are a baseline, that yes, if these matrices are covered, then boss, my I'm assured that my basic performance is not screwed up. So uh, there are like majorly there are like three web vitals which are critical, and if you measure them correctly, uh, you would be assured that yes, basic my website is performing well. So to start with, there is largest contentful paint. So let's say there is a website, and you are let's say there's a e-commerce website, and e-commerce website is having some banner or some kind of products to showcase. And let's say this there is some kind of banner image which is really important for the user, and that is the largest content. And now, by the web standards, if that piece is not loaded under 2.5 seconds, then there is something wrong. And people would try to jump the website because the content is not available. And there may be, let's say, small elements like buttons, or some small elements are there, but if the largest element is not there, not present, uh, yeah, it would like impact a lot. So you can start by measuring largest contentful paint. The next could be, because these days websites are more like web application, or if you consider a B2B web application, uh, it is more related to how the users are interacting with the page. So this matrix interaction to next paint, it would give you. So let's say on this, I'm running my presentation on Canva, so it is also a web app. So let's say I'm performing some action in Canva, and when I'm performing the action, the related reaction, or the related side effect, or the related action is not performed under 200 ms, then boss, there is something wrong in the way you are executing the JavaScript. Because what may be happening is, since the JavaScript or the JS engine is single threaded, there could be some kind of processing, that is heavy processing, that is happening, and your the browser engine is busy doing that processing, and at that time I am trying to use the web. So it would slow, and to measure that, you need to make sure that uh, the main events on your page gets reflected under 200 ms now. So now, the third important aspect which you should consider is cumulative layout shift. So what happens is, so let's assume that you are consuming some kind of a news website. Let's say in India, Times of India is very popular, or you can consider with New York Times or Washington General. Now the media is very much related to images or large kind of text. Now let's say you are reading the content, or you are, let's say, if you take the example of popular social media sites like Twitter, let's say you are scrolling through the tweets, and suddenly the image which is in the tweet is taking, let's say, a great amount of time to load. So what will happen is, since your eye is busy in reading that paragraph, and suddenly the image would appear. So what would happen, this image could lead to disturbance in the content which is currently in your viewport, and as a result of which, happen is what would happen is you would not be the user would not be able to keep track that where he was, and it would lead to frustration, and he would again like frustrated that what has happened in between. So this is again an important vital which we need to make sure. So these three are the basic vitals which we should check with every release, that yes, my largest contentful paint is happening under 2.5 seconds, my interaction to next paint is happening under 200 ms, and my cumulative layout shift. So this is a measure of how the large content is available on the web is under, the ratio is under like zero point 0.1. Even if it goes to 2.5, it is like somewhat acceptable, but if it is like going beyond that, you need some kind of improvement, or you need to like then rethink that how you have structured your HTML or the web content. Yeah. Now, when we go beyond web vitals, there are like broadly three categories of monitoring tools which you need to consider. So, I categorize it into like developer mode, which you can run in your browser. Then there are simulated environments, because you want to make sure that web is perfectly working fine on those environment. And then the third part is you need to see how the website is performing on the real users' devices. So let me pause this video. So this is again a chatting application. So what is happening is, so I need to make sure that yes, I'm playing around with this chatting application, but is my performance or is my memory under like given threshold? So this is one of the problems which I worked upon to solve. So this is the video of like few months back. So what was happening is when I was like profiling on this website, you can relate it to the Slack or the WhatsApp. So what was happening is, let me now play this video real quick. Yeah. So now if you see this graph, what was happening is, the as I was interacting with this actively, my memory graph was rising. And since the memory graph was rising, so like memory is good, but the browser should again retain that memory. So what was happening as a result of this memory leak is, because the in any device, the available resources would be limited. So what would eventually happen is, since the resources are limited, now the applicable uh, resources has been consumed by the actions. Now in between, if there is some other event which is happening, so it would lead to lot performance problem. Yeah. So now the other part of monitoring tool is simulated environments. So let's say the most popular simulated environment is web page test. So this is again, I ran through web page test for some of the popular website. And so this, what it would tell you is all the web vitals and all the important metrics is how they are performing in all the different devices. So you can like whatever device you want, let's say you want to test on a old Android phone or a latest iPhone, or you want to compare it with different versions of desktop. So that's how you can just it's a very simple interface. You can like go and paste the URL, and then it would start testing. Even like if the website is like logging prevented, you can uh, write a script over there. The script is the syntax of the script is very easy. You can write the script, and it would automate the system, and it would run through all the matrices, and it would show you that yes, on this devices, so my website is performing fine on all the desktop device, but on a old Android phone, the largest contentful paint is, let's say, 9.7 seconds. So this is something which is really poor. And now what, this is fine that, all right, it is 9.7 second on a given device, but it is fine for other devices. Now the next thing which I would do is, I would check that how much traffic is coming on that Android device, because that's how you would prioritize that how severe this problem is. If, let's say, a good amount of traffic is coming on that Android device, and your web is slow over there, you immediately need to fix it, because the users who are using this device are not able to consume the content which you are intending to. Yeah. Now after this simulated environment, the next set of tools which comes are real user tools. So there is a very popular Google Crux. So what Google Crux does is, it captures all the matrices from Chrome. So so let's say uh, it gets all the data on how your website is performing on different versions of Chrome, or people who are using like Chrome, whether it is phone or whether it is desktop. And that's how, like, I would see that on real users, my largest contentful paint is for desktop. Like for 76% it is really good, but for 15% it needs to be improved, but for the 8% of the users it is really poor. Now the next step, it I would go and see that who are these 8% of the users and which exact device it is. Now now if I compare desktop with phone, my 24% of the users are having really poor performance. So that's where I need to focus. However, if I go about how JavaScript is executing, I'm mostly fine, because for 95% it is really good on desktop. And since phones have limited resource, it is acceptable that for 87% it is performing really well. So by this matrix, I would at least have a first level of information that yes, first level of information and confidence that yes, this is the area which is working fine, but uh, largest contentful paint is something which is not working fine for the phone. So I will go and debug into that, what that content is. So let's say for me it is a large image, then I will see that okay, this is a large image. So what I may be doing wrong is I may be serving a large size image on phone, but it is not. And it is since the network or the resource on the phone is limited, and it is not very suitable for the phone. So after knowing that, I will like develop couple of versions of lightweight images, and for all the like user agents which are phone, I would utilize that image, and similarly I can like go about fixing it. Yeah. the other uh, the other real user matrix is you can utilize page speed insights API. You can like configure those page speed inside APIs under your code base, and it would like show you like how these metrics are performing on the devices, and then you can compare it with other devices. Yeah. So after covering all these like monitoring techniques, you may be like thinking that, hey, do I need to do all, or can I have a automated system? So yes, uh, you can utilize automated system. Yeah, you can utilize like tools like Sentry. You can utilize tools like LogRocket, Datadog to monitor the performance, or you can like also you can utilize like that, because all these matrices, let's say all these web vitals are internally JavaScript events only. So you can utilize that a performance JavaScript API, and then you can configure some kind of alerts. So let's say uh, if my DOM content loaded is going beyond this limit, I would like shoot a email to me that yes, hey, on this X system that currently my DOM content loaded, or my interaction to the next paint is happening. And the only way, because when we started talking about this, the only way to achieve this is if you have these systems in place from the very beginning. Because what happens is, more or less all the front end application would start really small, and then you would start keep adding the features to it. And since you are keep continuously adding features to it, it would largely impact largely impact the performance. And by the time you notice about it, it would be too late. And by late, I won't say that you won't be able to fix it, but it would take a lot of your energy, because now the code base has gone into that scale that now refactoring it has become tricky. And people won't like to like touch into the bases which are functionally they are working fine, but performance wise they are poor. So you can have these systems in place from the like these should be the base of your development cycles, that yes, my systems are in place now. I should like go about writing the code, and now I should go about like choosing the frameworks. And now even from the day one, I know that how it is working on real user devices. So to conclude that, uh, systems should be the like baseline. All the monitoring systems or the like web vitals should be the baseline, and then on the top of it you would like have certain processes under your dev team, like how you like write the PRs and all. Because uh, I know people may be thinking that why I cannot like review a performance problem from a PR. It is practically not very convenient, because uh, like PRs, you won't be able to know that hey, is this function heavy in processing and it would impact other places, or is this like image too heavy which would like uh, have my cumulative layout shift. And then on top of it, then you can decide patterns on the frameworks. Let's say if we talk about web, whether it is like React, or you want to go about a server side framework like Next, or whether you want to do a vanilla JS, because only and only if systems are in place you would be able to realize the importance of those patterns, that yes, I chose React and it is for more than 95% of the users, my page is getting loaded in 1 second and they are like able to perform their task in, let's say, less than 200 ms. All the events are getting fired, and that's the only way you would realize that yes, React was the choice that I made, which is correct. If it is not, now I need to like go into a different rendering pattern. Maybe it could be a server side rendering pattern and these kind of things. Yeah. So that's all about like enterprise web performance. Really happy if anyone has any questions or anything. Uh, I kept this talk more on like strategy and how you should utilize it versus the code patterns of it. Yeah, thank you.
Thank you very much, Atisha. It was really interesting. I really learned a lot from it. So, yeah,
Thank you.
thank you very much. Yeah, next we have next for our talks we have Abdul Basit. He will be talking to us about KMP and CMP. So he's a GDE for Android. He's a software engineer at SadaPay, and yeah, he enjoys working with Kotlin and particularly fond of KMP. So yeah, Abdul, you can be on stage. Thank you very much.
Okay, is my screen visible? Nice. Hello everyone. So today we will be talking about Kotlin multi-platform and Compose multi-platform. So we will be looking into like how you can start and what is Compose multi-platform. But before that, some intro about me. So my name is Abdul Basit and I am a GDE for Android. And I have been like working with the Kotlin multi-platform for around 2 years, like till now. And so far, like I'm quite enjoying. So today we will be going through that. So let's start with the multi-platform. So first of all, like when we say that this technology or this framework is multi-platform, so what it means? So multi-platform means that you write once and then that things run everywhere. So suppose if you are developing an application, suppose in mobile app. So if you are creating an Android app, so for that you need to write the code in either in Kotlin or in Java. And if you are developing an iOS application, so in that case, like you will be either going for the Swift or Objective-C. So you see that for that simple app, you are writing the code twice, once on the Kotlin and then again on the in Swift. So multi-platform means that you write your code once and then it runs everywhere. So with just single code, you are targeting multiple platforms. So we have some famous multi-platform technologies like Flutter. So in Flutter, you just write the code once, and then you can with that you can target Android, iOS, web, and also desktop. So Flutter is from Google, and then we have React Native. So in React Native, you write your application in JS, JavaScript, and then it will run on uh, all other platforms. So these are like different cross-platform technologies, and we have also some other like Xamarin, Cordova, and there are like some others, but these are the most famous one. So when we talk about multi-platform, the issue with these is that they are not native. So the native thing is like kind of debatable. So some people say that when the code, like the UI, uh, is same to same as the framework, like there are different principles in iOS and different principles in Android for navigation and doing different stuff like the dialogues and buttons. So they are different. So when you have the same UI, so some people say that that is native, but some people say when they share the same memory space in the RAM, so that means that the code is native. So in case of the Flutter or React Native, so they don't share the same memory space and they works via some bridging. So then we have Kotlin and Kotlin multi-platform. So with the Kotlin multi-platform, the situation is different. So when you are starting multi-platform and you are targeting different platforms. So in that case, the Kotlin compiles to the native language. So if you are developing an Android application and iOS application and you are going for multi-platform, so in that case, the Kotlin code will be in the backend. It will be we have a Kotlin backend, so that will be converted into IR, like immediate representative a representation, and then that will be converted to the specific platform. So if you write that code in Kotlin and you try to run that on iOS, so first of all the Kotlin code will be compiled into intermediate representation, and then that will be converted into Objective-C to the machine bytecode. So in the case of Kotlin multi-platform, so the code reside in the same memory space. And another thing with the Kotlin multi-platform is that like you can share as much as you want or as less as you want. So either you can start with just like some logic, you want to share that, and it is very easy to introduce in existing code base, like you just add some dependencies, and with that you are like open for the Kotlin multi-platform. And if you want to share the whole logic, Kotlin multi-platform supports that. If you want to share like just a bit, suppose events, so normally we have events, so uh, normally there is issue with the naming of the event. So on the iOS, on desktop, on web, so that they are different, so which like which disturb the whole funnel. So if you just want to go with the events, so you can also analytics in these stuff, so you can also do that. So you can share as much as you want or as less as you want. So let's go with the setting up our environment. So if you want to start with the Kotlin multi-platform, so first of all, you need to set up your environment. So for that, we have a command line tool which is called KDoctor. So that is the K doctor will be telling you that if your setup is okay or not. So it will check for the operating system, it will check for the Java version, and then the IDEs. So mainly you will be developing with Android Studio, so it will check if you have the compatible Android Studio version or not. Then it will check for Xcode and CocoaPods. So the Xcode, if you are targeting iOS also, so in that case you will be needing Xcode. Otherwise, you don't need that. And the CocoaPod, so that is like a framework for sharing dependency on the iOS. So like we have Gradle, so the dependencies are provided by CocoaPod. But if you are not targeting iOS, so in that case you don't need Xcode or CocoaPod. So once the K doctor say that everything is okay and the checks are green, so now that means that your environment setup is okay. The next is uh, with the KMM plugin. So if you want to do the Kotlin multi-platform development uh, with the with Android Studio, so in that case you need the KMM plugin. So this plugin will allow you to run the iOS code from Android Studio, and with with that, you like it will facilitate you in the multi-platform development. So once you install that plugin, so if you go to Android Studio and you try to create a new project, so there you will see two new templates. The first one is Kotlin multi-platform, and the second is Kotlin multi-platform library. So if you want to like just develop an application, so in that case you need to select Kotlin multi-platform. But if you want to develop a library, so in that case you can go for Kotlin multi-platform library. So that is like a template. So once by default that are not, they are not available in Android Studio, but once you install the KMM plugin, so they will be available there, and there you can start. Normally, if you want to start, so my suggestion is that you start with the template, because the things are already set up for you. You can also do that manually, but it's like very cumbersome thing. So better to do start with a plugin. So then apart from like we have the template in Android Studio, but apart from that there are also some other templates. So the first one is from the JetBrains. So you can go to the kmp.jetbrains.com, and there they have a template. So in that template you have to like give the project name and the project ID, and then we have if you want to just do Android development, so you can check the Android, and if you want to go for iOS, check iOS. And then we also have desktop, web, and server. So it depends on like which platforms you are targeting. So based on that you can select those, and once you select the checks, the required check, so you click on download, and your code will be downloading, and then you can start from there. So with the Kotlin multi-platform widget, we also have Kotlin multi-platform inside that gallery. So there are currently three different options. So the first one is that shared UI multi-platform application. So in that case, when you are using that template, so you will be sharing the UI along with the logic. And then we have native UI multi-platform. So in that case, you will be using Swift UI on the iOS end, and Compose on the Android end, and but the logic will be shared. And the third one is uh, the multi-platform library. So the next template is from the Terraoke, terraoke.github.com/kmp web visit. So this is like a more advanced version, because it also gives you the library, so you can target Android, JVM, iOS, Jazz, WASM, and we also have different libraries available. Like we have Kotlin coroutines, which you will be using for offloading the long running task from a main thread to the buyer to the dispatcher to different dispatches. Then we have serialization that we'll be using to serialize JSON. Then we have datetime. Then we have Kermit, which is like a logging library. Then we have Kitor client, which you will be using as a retrofit alternative for uh, client communication. Then we have SQL Delight, which will be used as a Roam DB, like saving your data and then retrieving those. And then we have Kotlin multi-platform settings. So normally in Android, so we have shared preferences. So in Android, we have shared preferences, so that is in the alternative multi-platform settings. And then we have build configuration. So if you want to do some build config, like set up different URLs for different environments, so in that case you can use build config. And then we have Coin, which is used for dependency injection. So you can start with that template, and it will provide you these libraries built in. So this is when you start with Android Studio. So this is how the application looks like. So we have Android app, then we have iOS app, and then we have shared. And then in shared, we again have Android main, common main, and then iOS. So normally when you are writing the code that the Kotlin code, so it will be in common, which will be shared again for all platforms. So we have this greeting, just the which is the greeting class, and then we have platform, a Git platform. This is a class in the shared code, the greeting. So the Git platform, that is like something that is shared across the Android and iOS. So here you can see that we are calling the Git platform, which is a function. And if you look into that function, so you can see we have expect fun and Git platform, and which is returning platform, and platform is an interface. So that code is in common. So in Kotlin multi-platform, so we work with expect in actual. So it is like same as an interface with different implementation. So you define the contract in the expect. So here we are expecting a platform, which is an interface, and on each platform we will be implementing that. So once you write expect, so the IDE will give you error that you need to run. You need to provide me the actual implementation for both of these. So in that case, this is the Android implementation, the iOS implementation. So we can see that we have class iOS, which is extended from the platform, which is the interface that we defined in the common, and then we have the actual function get platform, which is creating the instance and then returning that as an interface. So this is how like normally you work with the expecting actual in Kotlin multi-platform in case you need platform specific dependencies. So this is for the Android one. So here we have a class Android platform, which is extending from the platform, and then we have the Git platform with the actual implementation, and we are returning Android platform. So this is how normally like you do the expect actual implementation in the Kotlin multi-platform, and normally the functionalities that are available in the Kotlin language. So in that case, you don't need to provide expect and actual because they will work in the common code. So as I was saying that with the KMP, you can share as much or as less as you want. So if you just want to share a piece of logic, like you just want to develop a specific application of your app in the Kotlin multi-platform, so you can do that. And if you want to share the whole logic, just keep the UI native in Compose and Swift UI, so that can also be done. And if you want to share 100%, like you want the logic to be in Kotlin multi-platform in the UI, so that is also possible via Compose multi-platform. So and the actual implementation, we saw the expected actual implementation. So currently like we have common, so we created a function called expect function in the platform, and then on each targeted platform we are implementing that. So we have the actual platform which we are returning. So this is how like you can come you can uh, implement the platform specific dependencies. And this is like an actual example. So suppose you want to generate a random GUID. So the random GUID generation is done differently on Android and different on iOS. So in that case, we created a function which is called expect fun random UUID, which is returning string. So now that is in the common code, and now we need to do its implementation. So on the Android, we can generate a random UUID dot random UUID, and then we are converting that to string with an actual implementation. But on iOS, so we have in is UUID dot UUID string. So this is how like you can do the platform specific implementation. And now about calling that common codes from the Android and iOS. So in this case, we have a function which is called funGreet, and we are running a list in that case, and we have a random next boolean, so which will generate the next boolean, and if it's true, it will return hi. Otherwise, it will give us hello, and then we add another string which is like guess what it is, and then we get the platform name and then reverse that. So this is a function in the common code. And now if we want to call that from the Android, so that is pretty simple. So normally when you are developing a Compose application, so we have app, and inside that app we do our multi-platform. We call the composables. So we have app and we have material theme, and then we create instance of the greeting, and then we calling its function greet, and we have a column, and because the greet returns a list of strings, so we are having for each, and then we text and a divider in the middle of these texts. So this is how it looks like. So we have hello and guess what it is, and Android 34 is reversed. And if we look into that in iOS, so we also, because in the iOS, so the Kotlin code is converted into Objective C. So here we can create an instance of that. So we have phrases is equal to greeting dot greet, and then we have a list, and we are showing that text. So this is how it looks like. So here guess what it is, and then the iOS 17.2 is reversed. So if this is the case where you are calling the common logic from the common code. And now about the ecosystem. So like how strong is the Kotlin multi-platform ecosystem? So before some time ago, it was lacking a bit, but now I think we have a lot of libraries. So we have a repository which is called KMP Awesome. So in which there is a list of libraries that are supporting Kotlin multi-platform. So the list is quite long. So we have dependencies for storage, we have dependency injection like Wine, and we have SQL Delight, we have for navigation. So we have Decompose, Voyager, and Jenkins Compose, and also we have saw some other libraries like the K-store and the multi-platform settings, and with the Google I/O. So there are a lot of the Android libraries that have started support for the Kotlin multi-platform. Like we have Rome, we have View models, and a lot of starting support for the Kotlin multi-platform. So we have Compose navigation currently supported, which like still does the navigation based on the strings identifier, but soon we will get the navigations uh, arguments. So I would say the ecosystem is getting better and better day by day, and every day there are new libraries coming up, and it's going pretty good, I would say. So now let's move toward Compose multi-platform. So we talked about Kotlin multi-platform, but what is Compose multi-platform? So this is like a UI framework that is built on top of Android Compose, and it is a fork of that. And whatever like you can do in Android Jetpack, that the same thing can be done in Compose multi-platform. So on the backend, it used, I think, Skiko engine, which renders the UI for on different platforms. So that is a very simple application that I created with the Compose multi-platform. So circular fillable loader, and that is built on top of Compose multi-platform. So it is targeting Android, iOS, web, in desktop, and the same code is being run on each platform. And if we talk about frames, so the frames are really good, and they are like they're I like it's very smooth, I would say. And because the more and more Android libraries are getting support for the Kotlin multi-platform, so the multi-platform application development is like now developing an Android application, because you are doing the same stuff. There is just one entry point. Once you enter that, so inside that, that is like just Android application. So let's look into an example. So in this case, we have a simple application, a function which is called a, and we have material theme, and then we have a show content boolean. On top of that, like it will either we have animated visibility, so either the image will show, or it will be gone. So that is like a simple composable. Now we will be calling that composable from Android and iOS. So from Android, so that is pretty straightforward. You just call the set content, and inside that you call that composable. So we have the app composable, and we are calling that so the app composable in the shared code, and we are calling that from the Android. So you just call the app, and now you are inside, your code will be rendered. And inside the iOS, so for that we have to use the Compose UI view controller. So we have the main view controller, and which is like a Compose view controller. Inside that we are calling the Android, the our Compose multi-platform app composable. So that main view controller, you can call that inside in Swift UI, and it will render that Compose uh, UI. And one thing that you can also call like so suppose if you have a Swift application and you want to just share a specific UI part, right? So that is also possible. So with the Compose UI view controller, you have to call that function, and with that you will be able to render your composable inside Swift UI. So that is also possible. And regarding the Compose navigation, so we have Decompose, we have Voyager, and as I mentioned that recently we got the support for the Compose navigation. So if you want to go on that path, so that is also now available. So we also have some other libraries that support that provides the compose multi-platform navigation. The one is the Apex. Yeah, I think if, from the Bumble tech, so we also have Epic. So there are multiple navigation libraries that we can use. And regarding the Android libraries that support KMP, so we have view models, we have data store, we have room, and we have lifecycle. So currently we also got the lifecycle support. And regarding the IDEs, so when you are developing compose multi-platform or Kotlin multi-platform application, so depends like what you are targeting. So the main IDE is Fleet, but Fleet like still lags a bit. So with the Fleet, like you can launch your desktop application, you can launch your web application, you can run those, you can run the iOS, and you can run your Android application. And inside Android Studio, so if you have an application that is targeting all of these platforms, so you will be able to just run the Android and iOS application, and for the desktop and the web, so you have like to customly write the command inside the terminal. And sometimes you need Xcode, uh, and IntelliJ is for the uh, web and for the desktop. So like you will be using, because I'm using all of these, the fleet is like doing quite good, but sometimes like you have to switch between different IDEs because one thing is available and the other thing is not available. So you have to like switch from one IDE to another IDE. So that was it regarding the Compose multi-platform and Kotlin multi-platform. So hopefully this session was provide some insights on the Kotlin multi-platform and Compose. And if you have any question or like any query or any curiosity that you want to know about the Compose or Kotlin multi-platform, so you can get in touch with me either on Twitter, on the LinkedIn, or on GitHub. So just drop me a message and I will try to respond. So that was it. Now, if you have any queries, so I would love to answer those.
So
Let's see if
thank you
you
very
have
much,
any.
Abdul.
Yeah.
So yeah, we didn't get any messages. So guys, if anybody has any question, you can send in the comments.
Mm.
No. So yeah, I think everybody understood everything. So very good session. It was really
Yeah.
understandable and really easy to understand. So thank you very much, Abdul.
Thank you.
Yeah, and now for our next session, as we are moving a little bit slow, we have with us today Thomas, and Thomas is focused on everything that's JavaScript related. He's experienced trainer and conference speaker. He's an independent consultant, developer, and architect at Duncan.dev, right?
Yeah, Duchin.dev.
Yeah. Okay, sorry. And he talking with us today about how to get rid of the impossible state with a very scary face. Oh, please, you can start the talk. Thank you very much.
Okay, so thank you, Ahmed, very much for having me here. So the title of the talk is "Get Rid of Impossible States." So as you can clearly see, like the title states, what is the problem? So when we manage state, we need to manage things like how do we model the state, what it is, what shape it has, but also how does it change over the time. So one of the issues that we need to handle, that we need to take care of, is we might have some state A, some state B, some state C, etc., but not necessarily every piece of state exists at the same time. So sometimes it could happen that bugs are caused because we walk into impossible states, because simply like nobody is perfect, everybody make mistakes. Like I also make mistakes. Like I'm pretty sure everybody would also nobody is really bug free. Kind of nobody is. So the question is, how can we automate getting rid of some class of the bugs entirely? And using just a little bit of TypeScript knowledge, not even TypeScript magic, we can get rid of impossible states entirely without even using any external library at all. So we're going to use the concept of a state machine, though we're not going to raise the entry level by using any external libraries. All we need to know actually is how does TypeScript types and unions work, and that's basically it. So my name is Tomasz. Yeah, I'm a developer, architect. Most of the time that I spent right now is helping other teams to overcome their difficulties. The difficulties could be related to performance, to architecture. Mostly I'm working with JavaScript code bases and front-end generally. So most often I start meeting with a team pretty frequently, as much as the team kind of manages to overcome their issues, limitations, etc. Whether it boils down to the number of bugs, the speed of deliveries, the frequency of deliveries, the number of any kind of failures, downtimes, etc. The more stuff that we manage to do, the less frequently we meet. And finally, I just move on to another project. So yeah, I do consultancy. Recently, I started YouTubing. So take a look at YouTube, Duchin Dev channel. And also you can take a look at my Egghead courses. And recently I also started contributing to Angular DevTools, the core DevTools, although I spent a lot of time with Do Everybody React. So let's get back into the main topic, which is getting rid of impossible states. So in very short words, what is a state machine? A state machine is basically a representation of what our state generally could be. So here we can see some funny, colorful circles. So we have like state A, state B, state C, whatever that is. We're going to take a look at it in just a while. So the state is basically a point in time in which a state in a certain point in time that our model, our entity, our basically some things that exist could be in. And what is important, those states need to be designed upfront. Like if we don't do the design, then basically, we would have chaotic design, or basically everybody run for yourself design. So we could have leak of abstraction, we could have wrong abstraction, we could basically open ourselves to problems with type safety, with refactorings, maintenance, etc. So the whole point of working with state machines is that we try to design things upfront, so that when anybody would join our project after some time, they would basically know what was my intention. Like my intention, I mean, when we started writing something, implementing something, like what was my idea, what was my intention. And if somebody wanted to change the code after a year or two or whatever, just because the business came and said, okay, now you need to modify something, then how to craft your model, how to craft your design so that basically it won't collapse out of a sudden. So I pretty much expect that many of us have found ourselves in a situation that when we start a new project, a new module, a new package, whatever, we think that, well, it's nice, we're working in a green field, it's so exciting, new technologies, blah, blah, blah. But after 2 or 3 years, it happens what needs to happen every time, we find that our project is already legacy. So how did it happen? What happened that after 2-3 years it's again the same story? So to everybody, state machines allow us to model, to design up front what is going on here. So we are explicitly naming what is a certain state, what is the data that is being included in a certain state. So we can basically put what the data is over here right now, down here, and also what are possible transitions. So what we are going to focus on during this talk is actually mostly what are the states, because this is pretty simple to get under control within TypeScript. We are not necessarily going to speak about transitions because more runtime code would be needed. So we can also mention that here. We can easily solve the problem of moving between states and the data that is being included within a certain state. And transitions is actually something that would most probably need to happen in runtime. So this is doable on type level, though the code would not be necessarily very nice or very simple. Yeah, whatever we call it. So what would happen if we started working on an application, if we join an application? I have prepared a small application, simple application with some data fetching, and I would like to display a working example in React, just because it's just an example. Like, we could just use any kind of framework that is doing any requests to an external server. So what we've got here, dear everybody, is that we have just a little bit of tabs, and here we've got some data within the employees tab, and whenever we come here, we are loading the data. And as you can see, when we are still loading the data, then we have a spinner over here, and yeah, that's basically the simplest data loading possible. We have also some additional stuff, but let's just forget them for a while. The design that you can find, let's say that we are in a situation where we join a project, and this is the code that we've got here. The design that we've got is basically essentially 2 lines. There is some employees, the data, and the setter of set employees. There is also some isLoading and setLoading. So in React, that's basically the simplest possible way to create a piece of state. In modern Angular, that would be a signal. In Vue, it would be another thing. So basically the simplest possible state. So to everybody, the root of the problem is actually, first of all, that we're not handling errors, and you cannot even see like what is the whole design of the data loading, but also that these pieces of state are independent on each other. So first of all, what we're doing in this exact code is that we're just running a very simple function that runs sends a HTTP GET request to the server, and when the promise resolves, it's going to set the employees data, it's going to set loading, it's also going to set the completed rate, which we can actually just forget for a while. And to everybody, it's also missing the error handling. And okay, I'm just taking a look at something. This is the web and mobile track. So I should, sorry, Ahmed, should I move? No? Okay. Okay.
No, sorry. This is
Okay.
for the other speaker in the talk. Yeah,
Okay.
sorry.
Okay. Okay. So yeah. So if we want to introduce error handling over here, then let's just put one more, and that would be basically that we have an error, and we would have to set the error, and I'll just put the use state that could be an error. And now, dear everybody, of course, if we want to add error handling, let's say that we would have some kind of error, and what we do over here is simply set error and set loading to false. As you can see, I'm simply using the Copilot here just to slightly help me with what is going on here. So, dear everybody, there is a couple of issues already here. So when we initially start our application, something that I see really often in the code bases in the wild is that people like to start when they expect that, let's say, a collection would be an array of some entity, some array of objects, whatever that is that people start with empty array. And now, how would you differentiate a situation where initially you have basically no data loaded, right? So that you're initially just loading the spinner, from a situation where, let's say, you're trying to filter the data from the server and you're looking for people whose name is XXX. Like, nobody has name XXX, so you get an empty result set. How would you differentiate that? And apart from that, if you join a project, how would you find out, like, what the heck is an empty array? Like, what does that represent even? And moreover, another issue that we've got here is that how many possibilities could we have, like how many possible values could we have with Boolean state? So it's either true or false. So it's essentially 2. How many values, like group of values, could we have with this use state over here? Well, let's just generalize it that either we do have an error or we don't. So there is an error or not. So let's just simplify it to a Boolean value, again 2. And finally here with the employees, which is either, employees or lack of employees, which we, by the way, cannot even see from the type. So what we can simplify again is that either we do have the data or not. Now, if we multiply certain combinations, we get that total number of states that we've got is 8, right? Because 2 multiplied by 2 multiplied by 2. And now the question is, how many of them actually do make sense? For instance, is it possible that we would have an error that we are still loading and that we have some data set? Like, essentially, it makes absolutely no sense whatsoever. So if we would carry on, we would end up having the number of valid states to be either 3 or 4, depending on the situation when we have already loaded the data and we want to reload it. So depending whether while reloading, do we show the underlying data or no? So we could have like just loading the data without displaying what is underneath, or reloading the data as an additional state. So all in all, let's simplify it and let's say that we have 3 valid states. So what that means is that we have 5 invalid states. And this is something that happens really, really frequently, is that majority of the states that we've got, like potentially possible, technically possible states, are invalid. So if you ever walk into such situation, you're in deep trouble because this is a bug. For instance, you're displaying, at the same time, you're displaying the data and the error, and there is also a spinner. Or also that you basically have a spinner that basically never goes away because your if statement is put wrong, whichever language, whichever framework you're using, whatever. So, dear everybody, the thing is, how can we get rid of impossible states? So, the first and obvious approach is that, well, we should basically care about all of our use cases, right? So let's also use the idiomatic finally callback with JavaScript promises. So what we want to do is basically to set loading to false when we are done with the loading itself. And if we started, dear everybody, playing with this implementation, and we would be starting to implement the reload feature to this website and started, failing the network on the DevTools level and so on and so forth, we would find out that there is actually quite a lot of things that we would need to care about here. So let's say that when we reload the data, we don't show the old data just not to point the user into some, stale data, outdated data, etc. Let's say that we would like to basically clear it. So let's say that we need to set the employees whenever we start reloading. We would have to set the employees. So maybe let's also extract this function into the into a reload function. So let's call it function reload. So basically, that's the function that we're going to attach into an event handler. And whenever we want to initially load our component, that's basically a simple use effect, just to illustrate this pattern. So we're clearing the employees. And imagine a situation, dear everybody, where initially we walk into a situation where we have an error. So we set the error, and we would also like to display the error somewhere. Let's say that displaying our error would be some kind of span saying that error occurred, and it would say basically that you do have an error dot message, and of course message I need to put it like this. TypeScript cries because the error could be possibly undefined, right? So we could do like that. Or, dear everybody, we could also do it more, let's say, correctly and just make it wrapped with conditional rendering. Now, what is important here is that we are responsible for clearing the error. We have to clear the error. So in all possible cases, we need to remember to clear that down. And now, if we set the error, so we set the error that there is an error, and we set loading to false, all is cool. The thing is, dear everybody, that whenever we start reloading, then we would see both the error and the spinner. That's because we forgot to actually clear the error whenever we start loading. So this is one thing that we have forgotten. But also, dear everybody, when we start loading, we would see that after reloading, the spinner is not there. So we would have to also display it, as we can see over here. Yeah. So we have set loading, set employee, set error, and most probably I'm still missing some of the edge cases. And honestly, I don't care, because I would really be reluctant to implementing the code this way. So let's just quickly see. I'm clearing the loader. I'm setting the setter, setting the employee. So yeah, maybe I haven't forgotten about anything. Maybe the loader is here. The error was cleared. The employees were here. Yeah, still, there is quite a lot of things that we could forget about. So the problem is that, dear everybody, when we actually, our application has some design, like there was some idea, there was some intention, like moving from one state to another. But if you take a look at this crap, like how can you figure out what was the intention of the author? Like how could you even like figure out, for instance, let's say you come into such design, you come into such project, and you see, okay, a bunch of variables, neither of them is kind of dependent on each other. By the way, are they logically connected? Yes. Are they technically connected? No. And that's a problem. So let's say, if you take a look at this, could you tell me whether you are reloading the data, so not loading initially, but reloading the data, should you show the old data in the meantime? Can you anyhow figure out, should you display it or not? Like, do you see it from this design? Do you see it from this crappy code? I would say no. Like, what is the point of reference? Like, what should you look at in order to figure out what was the intention, what was the idea? In my opinion, the problem is that, well, this is lacking the design, because there is no place that I could see like what was the intention. So all in all, to everybody, the simplest possible solution to introduce state machines using TypeScript is basically to write down what is the whole point of determining a certain explicit states. So I'm just going to write a super simple solution using TypeScript union types. So a union is essentially, dear everybody, either this or that. So the compiler knows I will be in state 1 or state 2, but I don't know in which one. During compilation time, I know it's one of them, but I don't know exactly which one. So in this case, dear everybody, what we've got is, it could be, we could be still during the loading time, we could have a successful data load, and another one, we could have an error. Now, the point is that, dear everybody, when we create each piece of state over here, like you state, or a signal, whatever you're using, the thing is, if we can create a piece of state totally independently on other pieces of state, they can change independently. And that's not the case, because here, for instance, if I was in an error state and I want to reload, I need to clear the error. But the thing is, when I start to reloading, I should change all the 3 variables, all the 3 pieces of state together. So the thing is, I want to make my state changes in a kind of transaction alike manner. I want to change either all of them accordingly and consistently, or none of them. That's the whole point. So, dear everybody, when I'm loading, do I display any data? Let's say that the case is that no, when we have a loader, just let's make things simpler, only the loader is being displayed, but the underlying data, the old data, previous data is not displayed. So if we have a success, yes, we do display the data. So this is essentially the T array or T iterable of T, whatever. So we do have the data. And when we have the error state, then we do have an error. And now the thing is, dear everybody, in this approach, when can we access employees? Well, technically, always. Is it true, logically? I would say no. And it's even worse than that. When you reach out for employees, you always get an array, which is simply like, it's false. And now imagine, how come projects become legacy? Because you have written it, you knew what not to do, and let's say you put a lot of attention to write this reload function correctly. But after 2 years, there would be somebody less experienced than you, and the person would just have to, add something here, like how long would it take to basically display one more number here? Yeah, and the person would not know which stupid variable to watch for in order to not display the data that you should not display. That's the problem, right? So let's basically make it, dear everybody, impossible to make an error. So the thing is, our state is going to be, our, let's say, component state is going to be in one of those three, but we don't know in which one exactly. So what we want to do is basically to get rid of this crap, and we want to create basically one instance, just one instance, one piece of state, which is going to be essentially a use state or whatever other framework thing you're using, which is going to be of the type of this loading state union. And our initial, so this is going to be the employee state, just to put a different name, set employee state. And if we take a look at what this employee thing is, oh, I put just one triangular brace too much over here. Oh, no, loading state, that should be correct. All the structure elements are unused. Employee state. What is actually going wrong here? This seems to be okay. Let me just take a look here. Const use state load employee state. Maybe I made some typo. That should be type. That should be loading initially. Loading. Yep. So let me just const x. So what is x? X should be, of course. Okay, now I see it. I should be destructuring the array, of course, not an object. Sorry for this. So, dear everybody, we know that we are in one of the three, but we don't know in which one. And the thing is, if we want to access something, well, we need to check it. Like, you should not be able to reach for the data if you don't know whether the data exists at all. Like, this is nonsense, right? So all in all, I'm just going to comment this old reload function away. And what we're starting with, essentially, dear everybody, is that the initial state. So if I didn't put the initial state over here, then React's TypeScript bindings would basically put the undefined here. We don't want it, because what the heck is undefined? Like, what does it represent? I want things to be explicitly defined. So in what state am I? Like, I can always check. I can always explicitly check. If somebody joins my project, they at least know what was my intention. It's always easier to reason. Like, this is just 4 lines. In even a more complex state machine, it could be, I don't know, 10 lines, 20 lines, but it's at least a point of reference to start reasoning what is going on. So, dear everybody, if we're starting reloading, then what we essentially put here is that the employee state is actually loading, right? And when we walk into the if we walk into, like, if we successfully load the data, what we do is essentially set employee state into type success data employees, or whatever that is. And when we receive an error, what we're doing is essentially set employee state, which is basically an error, whatever it is. Now we don't even need finally. Now, what is the difference between the two? I don't even mean that there is basically fewer lines of code, because, well, honestly, I don't really care about the number of lines of code. I care about how simple would it be for other people to basically pick up my code and maintain it in the future. And, dear everybody, it is very simple to just forget about one of these setters. Don't do it, right? Like, I also sometimes I forget about these, because it's really difficult to figure out what are all the possible combinations. And what is important here, whenever you make a state transition, like walk from one state to the other state, we are transactionally replacing all the pieces together. Like, either we change all the properties or none of them. Moreover, if we want to put too many things, TypeScript is going to yell because it will the excessive property check of TypeScript is kicking in and saying that object literal may only specify known properties. So I cannot specify properties that should not exist here, which is cool. But also, if let's say I wanted to walk into the error state and I forgot not to put the error here, it will also say that, hey, dude, if you want to walk into the error, let's say substate, then you are missing the error property in the type error state. Like you forgot about something, right? So it's impossible to put too much. It's impossible to put too little. So, and it's so simple, like just a union of TypeScript objects. Okay, so I'm just going to get rid of this piece of crap right here. And no, sorry. We just need these things. I have already got rid of this crap over here. So sorry, that was kind of too much. And I'll just fix the errors that we've got here. So yeah, when we have, well, let's maybe walk into the template. So here I've got the error, and the error itself is not necessarily always seen. So what should we basically do is to check employee state dot type, whether the type itself is the error, and that's basically it, right? So if we are in the error state, I can just move it to the next line. Then we walk into the through the employee state dot error dot message. Somebody could complain that, oh, your code became longer. True, but on the other hand, if I don't go through the if statement, I won't be able to reach this data at all, right? So that's the whole point. Moreover, can you see that I was checking for the length of the array without even checking if I do have the length? This is not going to be possible from now on. And I am not going to be able to display something like length 0. Like, what the heck is length 0? I don't have any data. Like, I can have length 0 if I received an empty response. But if I have never had any response, then what the heck is length 0? It should not exist at all. So again, this is going to be now deadly simple. We are just going to apply the if statements. Now, this should not exist here. Again, why? Because if I'm trying to walk into the data thing, it will say, okay, this does exist on the success state, but it doesn't exist, for instance, on loading state. It doesn't also exist on error state. But hey, dude, I don't know in which state you're in, so you should probably move it down. So here, if I'm checking for employees, all we're going to do here is just to check for employee state type and check for success. So within success, we will know what is employee state.data. So we do have it here. And take a look. Here, outside of the if statement, we don't get any guarantee that the data is there. But if we move it right here, and I'll just for some React-related things, I'll just wrap it in a React fragment. Now, we can have that guarantee, because if we crossed this employee state, which was one of the three, we don't know which one, then when we cross the if statement, then we know which one we're in. And now, this is like a deadly simple if statement. But the thing is, we cannot overcome this if statement. And the last thing for today is that it could happen that you might need actually to do any calculation that is related to the data. And what we did is that we removed the guarantee that employees always, or whatever the data result is, that the employees always exist. So what people could do, again, would be, well, either the data is either the employee dot data or whatever, or we could basically put in that if employee dot type equals success, if it does, then it's here, or otherwise we'll just put an empty array. Now, again, don't do this. Why? Because again, what the heck is this? Like that's the whole point, not to do the thing, right? So we, although it compiles, we don't want to do the thing. So what would be the right approach? Now, you're probably using this calculate total salary. The calculate so just a sum, like array reduced, just a sum of numbers. So most probably this could be extracted into a subcomponent, right? And the whole thing is that let's create a subcomponent which will have a required employee array, and just let's embed it, let's display it within the if statement, so that the component will always have guaranteed that the data is there, right? And this will be inside the if statement, and we will be able to get rid of this crap. So basically, don't do it. I don't have time to do that, but basically we should extract a component which would have required data array property, and basically this if would be totally gone. So to everybody, after we save the application, it should basically reload. So yeah, it reloads to everybody, and as we can see, like completed rate is not shown, but the whole thing works. I haven't yet implemented the reload button, etc., but I hope this is clear enough that I would like to recommend, like I would like to encourage you to think of the design, think of what are the possible state, because there would be people who will basically get your code and will have to maintain it. And now, what is the point that they should relate to? I would like to see kind of a bit of design like this one, like this is the, by the way, the simplest possible thing. So if I came and I asked myself a question like, is it okay if I show the spinner, and should I also show what is the underlying data? Well, if I don't see such state, it means no. But if I, let's say, see the reloading state, and it would include the data which is of type T, then I know, yes, you should. So this is basically the initial state, initial loading, whatever we call it, initial, whatever. And yeah, so so all in all, dear everybody, what I would like to leave you with is think about the people who are going to maintain the code after you. If you write explicit design, so design up front, people will be able to evaluate whether your ideas make sense, and secondly, whether the solutions that you decided, whether they still make sense, like whether they still hold, or maybe due to changing business requirements, we should refactor or rewrite some piece, like change some assumptions. If we don't have it, how can we figure out what did the code author had in mind? So let's make it simpler for our future colleagues. And yeah, if you don't even mean to use libraries like XState for advanced and bulletproof and fully fledged state machines, just consider the bare minimum of TypeScript object unions. That's all from me. Thank you very much.
Thank you very much, though. So I think you pinpointed all the pain points for software developers nowadays. So thank you very much. It was a really interesting talk, and we learned a lot from it. So,
thank you.
You're welcome. So next up, we would like to go for the next speaker before the break. So the last talk before this break. So we have, I hope I'm saying it correctly. So he's a senior front-end engineer. He's a lifelong learner and Angular enthusiast. He'll be talking about one of the very good features of Angular, leveraging the ng component outlet to build a scalable and extendable Angular application. And please join our stage. I think you're muted. Yeah, you're muted, I think.
Okay, can you hear me now?
No, yes, we can hear you.
Okay, let me share my screen.
The stage is yours. Yeah.
Okay, I guess you seeing my screen, right?
Yes. No, I can see your screen. Yeah. Take the stage. Thank you.
Okay. Hello, everybody. Thank you, Ahmed, for having me today. And I'm really excited to sharing about the topic in Angular, how to leverage in ng component outlet to build scalable and maintainable Angular applications. First of all, about me, my name is Hin Phạm, and I'm living in Ho Chi Minh City in Vietnam. And I'm an Angular enthusiast and lifelong learner. And I'm also the member of Angular Vietnam community. If you don't know this guy, this is Châu Trần and this is Trung Võ. They are both Angular GD and they are from Vietnam. This is when we have Angular meetup in our local. And last but not least, I'm very honored to see my name in the special thanks of Angular version 12. Yeah, enough of self-promoting. So let's move on to the agenda today. First, I will talk about a practical example of the project I worked on years ago, and talk about the problem we have and the steps to clean up the code using the ng component outlet. Okay, imagine building a web application that allows you to buy courses, and we need to build 2 pages: the course listing page, this, and the course details page, like this. And in the course detail, we have a call to action button here. Okay, and for simplicity, there are 2 types of course, online course and workshop. For which course type, the text and the behavior of the call to action button here will be different. And exactly what is the difference? We have the call to action button text map like this for online courses and for workshop. And if the course is free, we have the start learning button. If the course is paid, we have the buy for price. And for workshop, we have enroll now and register for the price. And in reality, we have lots of types of course here, more columns in this table. And we have more factors that determine the text, the behavior of the call to action button here. Yeah. And how would we implement this requirement with the call to action button? Let's talk about the naive approach to implement the requirement. This is the HTML template of the component. When we nested if else here, we check the course type, the price, and we render the button and the label and the action. And this is the component class when we combine all the cases in just one component. And in fact, the size of this is around more than 500 lines of code just for one call to action button. What is the problem with this approach? So we see that we have nested if-else statements that make it hard to scale when we have multiple types of code. And we have different factors to indicate the button text, like the price, the user status, the subscription status, or the payment method. And it would impact the scalability of the project. It's also challenging when we have bugs occur in the component, and it's difficult for us to debug it in terms of maintainability. Okay, we do it better. Yeah, of course, yes. That's why we have the talk today. We can clear the code by leveraging the ng component outlet in Angular and the strategy pattern. So first of all, let's talk a little about the theory. What is ng component outlet? In Angular documentation, the ng component outlet instantiates a component type and insert its host view into the current view. The ng component outlet is a declarative approach for dynamic component creation. We can think of the ng component outlet is just an outlet of the main electricity in the world. And the call to action button is kind of the variance. We need to choose which one we will plug into this outlet. And what is the strategy pattern? According to Wikipedia, the strategy pattern is just a behavioral software design pattern that enables selecting an algorithm at runtime. So we can think of a strategy is just a man in the middle here thinking about which one should we choose to plug here based on the input data, the context data. In this case, this is the cost, the detailed information of a cost. Okay, and this is the 4 step of the code refactoring. In the diagram here, I will go from left to right, and we will come up with the step from right to left. Okay, first we have the call to action button, for short CTA button component, and inside the component we have the component outlet directive, and the component use the call to action button service and talk to the service that, hey, I want to get the component based on the cost detail that I pass in. In terms of the component CTA button service, it will use the strategies to select which strategy it will use to render to get the component class. And for the strategy, it will have their own algorithm to select which CTA and variation it will have here. For example, we have start learning, buy for price, enroll or register, and so on and so forth here. Okay, so the step number 1 is that we will define the call to action button variations. As you can see here in the mapping, we have 4 call to action button variation. In this example, and then we define the strategy. In this case, we have online course strategy and workshop strategy. And in the future, if we have more course size, we will just have more strategy here. And after that, we define the CTA button service. The service is use the strategy and call to get component. And then in the component, it just inject the service and pass it to the component outlet. Okay, let's move to the demo part. This is the simple Angular application I just created, and this application have the feature module courses. And inside this this feature, we have 2 pages, the cost list and cost details. We also have the call to action button. When we have the variations, we have 4 variations here. We have some strategies, 1 service, and 1 component. Okay. First, we will go through the variation to look for the start learning button here. As you can see, this is just a simple presentational component with the button and the action, and it accepts an input here as a cost detail, and the label is start learning, and the action is go to the start learning page. For buy for price button here, it's just a simple component like the previous one, which the button, the action go to the payment, and the input of the cost details. And the same for enroll now or register. Okay, this is the variation of the call to action button. The step number 1. Step number 2 is define the strategy. For the strategy, we have the command interface here. We have the method of get component and accept the cost detail as an input and return a promise of a component. I will explain why we have the promise here later on. Okay, let's move on to the button on CTA button online strategy. As you can see here, we have 2 parts. The first part is the first one it is this is where we declare the type of lazy loaded function, a function to lazy load a component, and this one we declare function to lazy load the start learning component. As we can see here, this is the function and we import the component. This also the function and we import the component. And we have the component map when we have the free price is free, we have the start learning component, and when it's paid, we have to buy for price. This is the map we use later. And the second part is the strategy itself. It will implement the interface here with the get component method, and inside this we will check the price and determine the key. With the key and the map, we will determine which component we will use, either this or this, and we load this component by calling a function. Okay, and the same for CTA button workshop strategy. We have this part to declare the components that we will use for this strategy, and the second part is just load the component based on the condition. And next one, we have the strategy map. When we map the cost type, this is the online cost, we have the online strategy. And if it's a workshop, we have the workshop strategy. Okay. The next one, we will have the CTA button service here. The service is just a simple function get component, and based on the strategy map, we get the strategy. And when we have the strategy, we will call the get component and input the cost here. Okay, so why we return the promise in the interface at the beginning? This is because we lazy load a component, and the return type of this one will be a promise. This is a promise of a class component class. Okay, and then when in the CTA button component, this is the code of the component. We will have the ng container, and we will use the ng component outlet from Angular. The ng component outlet here is from Angular command package. Okay. And to pass the data for the component outlet, the call to action button accept an input parameter of cost detail, and this is a signal, and we convert it to observable, and we switch map to call the service to get the component. This is the service that we defined earlier to get the component based on the cost details, and we have an observable of a component class, and we pass this one into this, and we use the async pi to get the data for the component outlet. And ng component outlet also support to pass in the input here. As you can see, let's open the call to action button variation side by side, and you will see okay, this is one of the call to action button variation, and we will see it will accept the cost details as the input. Okay, and when we pass the input here, this one, cost detail and cost detail is the same thing. And the cost details, the signal we have here, we will pass as the value here. So actually this value of the cost detail will be passed to the component here via the input in this. Okay, and in the page we just use the component. We have the pages cost pay cost detail here, and in the cost detail we receive an input of cost ID from the parameter, and we convert it to observable and get the cost by ID from a service, and we have the cost detail, and cost detail will be passed to the template here, and in the template we use CTA button that we defined earlier, and we just pass the cost detail with the value of the cost here. Okay, why we have the cost ID here? Because I config the route here. We receive the cost ID from the path parameter, and in the app config we have the with component input binding. Okay, so that's the code for the call to action button, and I already opened the demo here. So this is a simple demo that we have for courses. Two courses is of online type, and the other one is of workshop. And this is free, this is paid, this is free, and this is paid. When I click on the first one, you will see this is online course, and free, it will display the start learning. And when I click on that, the action is navigating to learning page. And you can see in the network, when I select the JS here, only when I go to the cost detail, the code of the start learning component, this is the start learning call to action button component, will be loaded. It means loaded on demand. And when I go back, when I click on this one, this is enroll now. And when I click on this, you will see another action, another behavior of the button. And in the network tab, we also see that we enroll now code loaded. Okay, if I click here, we will see buy for $99. I will navigate to payment page. And for this one, register, navigating to register form, and it's also lazy loaded. And if I enter the cost that doesn't exist, it shows cost not found. Or if I enter number one, it will show start learning. Yeah, it means that it will load it reactively when I go by direct link or when I go by. Okay, so that's the demo. And what will be the benefit of this approach? First of all, we will see that the call to action button strategy, we can add more or we extend no matter how complex the requirements are. The call to action button variation will be loaded on demand as we can see earlier, so it would be not the bundle size of the Angular application. In terms of maintainability, we can see that we refactor to remove all the business logic in the component template, and we centralize it in the strategy, And the strategy now is the single source of truth of the rendering logic. Okay, with that, I think that's it for my presentation today. And if you would like to see more about the source code, I put it in the slides here. And yeah, thank you for watching. And I would love to connect with you guys to see about your feedback, about your thought of this approach. Yeah, thank you.
Thank you very much. So it's a very interesting talk. I really liked a lot also. So yeah, thank you very much for this talk. And guys, so now I think it's time to go for a little break. So we will be back at 8 with 8 in Germany time. So yeah, so this will be in 1 hour, so 50 minutes exactly from now. So see you later, guys, and enjoy.
Thank you. Bye bye.
Thank you very much. Thank you. Bye. This yeah, a wonderful speaker. I always love to attend this talk. So he's a Google developer expert. He's also a trainer, a consultant for Angular architects. So one of the shows that I think most of the people, or at least me, I always enjoy is NG News, which is weekly on YouTube. Welcome on stage, Rainer. Thank you very much for being here. Waiting for hearing about testing in 2024.
Exactly. Right. Yeah, so thank you very much.
You're welcome. The stage is
I will
yours.
start sharing my screen, and if that's fine.
Yeah, sure.
Sure. Okay, good.
Just need to here.
Yeah, you just tell me when I can start. And
yes, now this screen is shown. And stage is yours. Now you can start.
Okay, good. Thank you, Ahmed. Thank you. All right. So hello and welcome to my talk, Testing in Angular 2024. So I had already the introduction from Ahmed. Also, thanks for the NG News promotion. So yeah, don't have to say anything about it anymore. And we just get started. So about the agenda. It's a very short talk, so just 30 minutes. So not so much time available, but we will first start, or I will first start with the testing categories, defining what kind of testing types we have. Then we will take a look at the testing strategies. So if we want to say there is some kind of a generic approach that you could follow, a guideline, then this is about that. And then afterwards, we come to the actual testing tools. So what we currently have available, and also what we can expect in the future. Good, about testing categories. So you might be surprised if I'm telling you that all these terms like unit test, integration test, end-to-end tests even, they are not really specified. So it's not like there is somewhere a specification that says a unit test is exactly this and that. So it happens very often, there is some kind of misunderstanding if I have a different interpretation than somebody else. And since I want to avoid this, I will tell you now my definition of those terms so that you know what I'm talking about. And if you say, no, I have a different understanding, for example, for a unit test, then of course that's also fine. Right, and I will follow the typical testing pyramid. We will then challenge if this is still a modern way on how to look at testing, but at least from the testing names, we will stick to it. And we will cover the unit tests, integration and component tests, and also end-to-end tests. So when I speak about unit tests in Angular, then what I mean is that my test tests a TypeScript class, which could be part of a component, part of a pipe, could also be a service. And I don't care about the template. My test only communicates with the TypeScript class. So I'm calling methods, and I'm also asserting against the properties. And when it comes to the dependencies of this TypeScript class, then I try to mock all of them. Not just try, but I just mock all of them. So this is my definition of a unit test. Only TypeScript class, nothing else. Then we have the component test. Component test means, in my case, my test is still kind of focusing on one particular component, obviously, but just one. And my test talks or communicates with this component via the template, via the HTML. So I click on a button, I type something into input fields, and when I want to assert something, then I'm not going into the TypeScript class, but I'm asserting something which is rendered in the DOM. This is what the component test is doing. In terms of mocking, it's very similar to the unit test. We still try to mock everything which is not part of the class. Nevertheless, with the component testing, you can't just say you mock everything, because the typical use case is if you have a form there, then you can't just say I'm mocking the template forms or the directive-driven forms, then it doesn't make sense. Then you don't need to write the test at all. But this kind of trend that we try to mock is one of the major attributes of a component test. And then, of course, we also have this definition of an integration test, where I would say, yes, I'm still communicating with the component via its template, but in terms of dependencies, I try to include as much as I can. Can means it always depends, of course, on the application. But at least there is a tendency that I'm not just saying in the beginning, I mock everything, but I try really to include as much as I can. So all the things, all the dependencies which are necessary for the component to fulfill its tasks. Those things which I will definitely mock are, for example, the HTTP client. I mean, that's clear. And then, of course, you also have some kind of, in larger applications, something like a user service or so, then you probably also want to mock that one because you don't want to open a connection to an OAuth2 instance or something like this. Yeah, and when we talk about an end-to-end test, then it's also clear our test doesn't even care what kind of framework we are using. It just says, I am remotely controlling the browser. This is what I do. So the test really acts as a manual, as a real person would do. So these are the four kind of definitions of the tests that I'm going to use. And then the question, of course, is what should we now focus on? So should we write only end-to-end tests, only unit tests, or what can we do? Of course, it's always a little bit hard to say this, to make this kind of general statements, but I want to give you some kind of guidelines, hints. We need to talk about the advantages and disadvantages of these 3 or 4 testing categories. So when it comes to unit tests, then it's clear that they are fast. I think we can all agree on that. Unit test is the fastest test that you can have. And that's also why the testing pyramid says, right, most tests should be unit tests. They're also very precise. What do I mean by precise? I mean, with the possibility of mocking that I have, I can really define, configure how my dependencies should behave. And I can really go down to a certain point in my class and can test if it behaves differently, if maybe, I don't know, if an HTTP client returns this or that result, or if another service behaves this or that. So this is something which I can do very easily. And they're also, relatively speaking, very easy compared to the other ones, component integration tests, because in unit tests, we only have to manage asynchronous tasks and mocking. That's what we have to do, and that's it. Of course, there are also some disadvantages. Low coverage. So I write a test, and again, this depends on what I'm going to test. But if I have a service, for example, that's the typical use case. The service injects an HTTP client, and it just has one method that calls the HTTP client, then what do I want to test? Yeah, I can cover this particular line, but the question is, is it necessary? And especially with small classes, we do have this drawback of low coverage. No refactoring, this is even more significant, because what you cannot do when you only have unit tests, that you say you are merging services together, you are splitting services, you are doing a refactoring, which means to the outside, the application does not change, but to the inside, it could change quite a lot, but the functionality stays the same. Now, what I cannot do, I cannot expect that I do a refactoring without touching my unit tests. And once I'm done, I'm just running all those unit tests again. And when they turn green, I know that the refactoring was successful. That's not going to work, because as soon as I start to change a class or just split the class into 2 pieces, I already have to touch my unit tests. That's the problem. And then also, and this high maintenance cost, this is a little bit special. The point here is, because they are very easy and because they are very fast, we tend to write quite a lot of them. And we don't forget that the more unit tests we write, the more we also have to maintain them. And then we have these typical scenarios where developers say, oh, I'm done with this feature within an hour, but it took me half a day just to update my unit tests. And this is then the main problem. Good. Integration component tests. I want to focus more on the integration part, so where I more have this tendency not to mock everything. And here we could say, in terms or relationship or in comparison to the unit tests, they have a better coverage, obviously, because we don't mock everything. We also include more parts, not just the component. I can do a refactoring. So if I say, well, I don't care what the class name is or whatever, or what kind of dependencies I need to mock there. I just don't care about it. I just want to say, yeah, there is an input field. I want to type something into it. There is a button. I want to click on it. Well, then I can say, okay, my component now has 2,000 lines of code. I'm splitting it up into 5 different subcomponents, services, especially with a standalone. That's very easy to do, and I don't have to touch my test because of that. So this is a big plus that we get with this kind of testing approach. Lower maintenance costs means, or because I don't tend to have so many of them compared to unit tests. And of course, when we come to the disadvantages, they are very hard to write. So it's not easy to write an integration test where you have to deal with asynchronous tasks, where you have to deal with the test bed, with the DOM, with the change detection, and then also, of course, manage quite a couple of dependencies altogether. So that's not easy. And the other one, of course, is that they are slower than the unit tests. I think that's clear. Good. And then we have end-to-end tests. In terms of end-to-end tests, they are extremely easy to write. So everybody who has already used, for example, Cypress, I think would agree on that. Then we have this kind of advantage that it is implementation independent. So even much better than possibility of refactoring. We could even switch the framework if we want to. Our end-to-end tests would not fail unless we really change something in the functionality to the outside, the way how the application behaves. High coverage, although careful about this argument. High coverage, it does not mean that much. So code coverage in general, careful about this metric, especially with end-to-end tests. You can just open a page with Cypress and you say visit, and then you have already a huge amount of coverage just because the application has to run itself, needs to start up with its components. Careful about that. But definitely, you cover quite a lot with a single end-to-end tests. It's hard to identify errors. That's on the negative side. So if there is an error, then with an end-to-end test, we are in the same position as an end user. I see maybe an error in the console, but I have no idea how that error has happened. Of course, in the stack trace, I see the file and that stuff. But in order to find it out, I have to go to a unit test, or maybe integration component test would also work. But as I said before, when it comes to the precision, unit tests are really great. And then, of course, we also have those challenges, especially for those tests that also want to include the backend or the infrastructure. That's not easy, especially if you want to run them the end-to-end tests in a CI environment. You need to set up the database. You need to set up the backend. If you don't want this, then you need to find a way how to mock your infrastructure. So it's not very easy. And of course, they're very, very slow. So you will not, we say it's good to have end-to-end tests, but the problem is we cannot have an infinite amount of end-to-end tests. That's not going to work. There is very soon a limit that you hit, and then it's over. Then you can't add anymore. Good. So in a way, the question is now, okay, what should we now focus on? Should we go with the testing pyramid style that we say unit tests are the best ones? I focus on that one, or what should we do? Over the years, there was a change in the way how we perceive testing strategies. And especially in front-end applications, where a typical front-end application, let's say a typical, doesn't mean that yours is typical, we don't have so much logic, which means unit tests don't tend to be so precious for us, because we don't cover so much with them, especially with those applications where you say, I'm fetching some data, I'm showing it, and then I'm sending it back. So where's the logic there? There is not so much logic. And that's why we tend to say, well, maybe the testing pyramid is not the right one. You see here two different alternatives. We have from Spotify, although that's not for front-end testing, but still it shows that the integration task, the integration part is quite valuable, the honeycomb. And then we also have from Kent Dots, I hope I have written his name right, the so-called testing trophy. He also uses here the static part, which we probably don't require in Angular. I mean, we have TypeScript for that, but nevertheless, also integration test is key here. And this is something which we can say in general, if we have not enough time to write tests, if we need to spend it wisely, efficiently, then integration tests, starting with integration tests, is a very good choice. So this is about the testing strategies a little bit. And then, of course, the question is also, okay, of course, now if I should focus on integration tests or on component tests, what kind of tool do I have available? Or what can I do there? Now, in terms of tooling, let's forget that slide. In terms of tooling, I mean, we have here again a new representation of the testing categories, now not with the testing pyramid. In terms of tooling, we all know that Angular comes with Jasmine and Karma, and we also have here Modern Web. So I see this as one group. Jasmine is the testing framework. So Jasmine provides the commands that we write. So if I say it, if I say describe, if I use my assertions, these are all commands of Jasmine. Now, the problem with Jasmine is that it is a testing framework for Node.js, and it is not aware of the web API. So if in one of our tests, somebody says document create element, then Jasmine will say, okay, I don't know what this document is all about. So we need some kind of a web API. And this is where Karma at the moment is interesting, because Karma takes the Jasmine tests, takes our code and runs it inside of a browser. So this is what Karma is doing, just a kind of a vehicle or a transporter to put the Jasmine tests into the browser. There is the web API. There it can do its rendering, or however you want to call it, and that just then works. Now, Karma at the moment is deprecated. We don't have a stable successor yet, but we know that the web test runner is the one that will succeed Karma. We also know, at least according to last week's Q&A session, or 2 weeks ago, that the web test runner will not make it into Angular 18. So it's very likely that we have to wait for 19, and then this web test runner will be there. Because the code, the commands, the API that we use are coming from Jasmine. And because nobody wants to deprecate Jasmine, we can expect that we don't have to do anything when the switch from Karma to the web test runner happens, because it's just the same code. It's just somebody else who takes our code, our testing code, and runs it in the browser. So there are some rumors Jasmine will go away. No, it will not go away. It will stay where it is, and we will just use a modern tool instead of Karma. So what about Jasmine? It's the official testing solution. I think this is important. If you say you want to go the official way, which is also supported by Angular, then it has to be Jasmine together with Karma. There are no issues. What we have seen in the past with the other testing frameworks, there are no issues with ECMAScript modules, because Angular is responsible here also for the build process. So all the testing files, all the compilation that is necessary, also, of course, all the components that are included in the tests, they are taking care of the Angular itself, and it just works. You don't have to care about it. And it's also proven. So, I mean, it's the testing framework of Angular, which means Angular also runs on Jasmine. Also, the Angular material is using Karma Jasmine. And of course, also the Google internal applications, very likely they will also use Jasmine. So if something does not work, the Angular team will fix it for us, and you don't have to care. Not so fast as others. This should not be a green thing. Yes, in terms of execution, we know that there are better things out there, and we have this kind of full browser support. What does this mean? This can be seen as an advantage or as a disadvantage. If you have tests that want to make use of the web API, I don't know, if you say you have a video tag or an audio tag and you would expect you don't want to mock it for some reason, or you want to access local storage, then you can do this with Jasmine. And of course, on the other side, the browser that we're using here is of course also an overhead for the tests. That's clear. That's the downside. And it's not supported by NX. That's the other problem with Jasmine. So if you use NX, you don't have an official support for Karma anymore. They have deprecated it last year. So, well, that's still another problem. In this case, you can go with the CLI, then you're happy. But if you want to switch, or if you're already using NX, then you have a problem. It still kind of works, but if you create a new workspace, you will see that it's not there. Then we have the alternative, which is Jest. So what's about Jest? Jest is the one that is the official supported testing framework from NX. It's also the major testing framework in JavaScript in general. So if you look at the download statistics, you see it's just huge. And it has things like parallelization support. So the tests run quite fast because they can be run parallelized. And we have this so-called affected mode. Affected mode, that means that in the development watch or in the watch mode, Jest is able to find out those tests which are affected by your changes and only runs those. So this is great. It also works out of the box. And the nice thing is Angular is working on an official support for Jest. So it then will also work with the Angular CLI. And again, Angular will take over if something doesn't work there. This is the good thing. But you have to wait. The priority is on the web test runner, Jasmine, and after that comes Jest. So I guess we are talking here about 2025. And that's the problem with Jest, is that it depends on the community contributions, on community itself. So if something breaks, if something does not work, and we had that in the past, then if you're lucky, somebody will fix it. If you're unlucky, then yeah, you can maybe do it, or you just wait and live with the things that are not working. That's of course, that could be a problem. And we have seen, especially with ECMAScript support in the past, that Jest tends to be extremely slow in terms of building, and it took quite some time until this was fixed. And also has to say, when it comes to managing asynchronous tasks, it's not that easy as it is in Jasmine. There are some pitfalls that you have to be aware of in Jest, but in general, it just works. So Jasmine, Jest, and we even have a third one. We also have vtest. What is vtest? vtest at the moment is, I would say, it's the most modern testing framework. It is based on Vite, which means it inherits the performance, which also means it's in general faster than Jest. There are some experiments with Jest though, where they are also using SWC in order to improve it. So there is I think a Twitter posting from Younes Chaidi about his experiments, but the native version of Jest is slower than vtest, because vtest again is running on Vite, which again is running on ESBuild, and they have these things aren't written in JavaScript, but in Go, if I'm not mistaken, which means extremely fast. They have Jest compatibility, which means your test code stays as it is. You don't have to touch it if you have written it in Jest. Jasmine is has a slightly different API, but in terms of transitioning, that's a good thing. And yeah, the problem, again, you can see it however you want, but you need to use Analog. That's again a community framework from Brandon Roberts mainly, also of course others. But you need to install the Analog platform, and then you have access to vtest as well. This is something you have to remember. And because it's brand new, so Analog isn't there that long, we don't have so much experience in terms of Angular. So it's kind of a newcomer in that sense for Angular. Good. So this is it about those kind of testing tools which allow you to write tests in terms of unit, component, and integration tests at the moment. We also have, of course, end-to-end testing tools. We all know that. I have mentioned it already, Cypress. So Cypress, in terms of end-to-end testing, at the moment, it's the most used end-to-end frameworks according to the download statistics. It has really a good developer experience, so you are very productive if you use it. And the tests, they're also very stable. There are some things in Cypress, if you know it, so you need to learn, of course, Cypress as well, but then you get the stability. And it's an official partner of Angular. So officially from Angular, Protractor is no more. And Angular said, well, we are not providing an end-to-end testing framework anymore, but we are doing partnerships with others, and Cypress is one of them. That's also a good thing. So there is some kind of channel. I don't know what the partnership actually is all about, what it includes, but it's a good sign if you, for example, say ng end-to-end, that Cypress shows up in that list. You can't do parallelization and test replay for free. You need to use the Cypress Cloud. So the more tests you have, the more you probably want to have that. As far as I know, the problem with Cypress Cloud is you cannot run it on premise. And you also, I think the data centers are not in Europe, which for European Union might be a problem. And there are some minor constraints that you have with Cypress, special things like multi-tab browser controlling or some other things. Yeah, and here we see the download statistic of all the official end-to-end partners of Angular. So I'm just focusing here on Cypress, but we also have Nightwatch, Puppeteer, and WebDriver.io. Those are WebDriver always Selenium based, but you see here one interesting thing. Puppeteer overtook Cypress and then it declined. So Cypress again then overtook Puppeteer. And there is a reason why Puppeteer is currently declining, because there is another framework, another end-to-end testing framework, which is currently, on a very fast pace. And that's also the second one that I want to present here, and that's Playwright. So this is currently the newcomer, or maybe not newcomer anymore, but we can say with quite a certainty that Playwright is the future number one in end-to-end testing framework. I think it's, if you just look at the download statistics, you see the rise, then you will just see that this is just a question of time. It has things like parallelizations, all those things that Cypress might have in the Cypress Cloud or might be missing. Playwright has that more or less out of the box. Playwright comes from Microsoft. And what they did is, of course, they took the best parts of Cypress, tried to improve it. And those things which were not so good, they didn't try to kind of repeat these things, but maybe go with an alternative. So this is what Playwright is all about. Very good end-to-end testing frameworks. And here we also see we don't really have any constraints, because we have, in contrast to Cypress, 100% full control over the browser. Can do whatever we want. It's not an official partner of Angular. This is, I think, also important for some enterprises. And you see here the download statistic. And I said before, the interesting story about Puppeteer is because it had a decline, and it's very likely that Playwright is the reason for that. But you also see here in the blue color, that's Playwright. You see its rise since 2022. The orange color is Cypress. And as I said, you just need to look at the download statistics, where Playwright started at the beginning of this year, where Cypress started, and how it is now. In the meantime, in this 5 month, Playwright has already kind of got 1 million more downloads. Not that with Cypress. So these are the kind of tools that we have available at the moment. And then we have a very special use case now. Of course, the question is, what should we want to use? But when it comes to integration and component testing, we have now the situation that both end-to-end frameworks also provide a component tester for Angular. With Playwright, I will say a little bit about Playwright. It's not officially released, but we can already say we have it. And if you say you don't want to use one of the component testers of the end-to-end frameworks, but you want to go with Jasmine or Jest or vtest, then I would say you need something more. You need one additional tool, one additional library on top of them in order to make your life a little bit easier. Because integration component testing, especially integration testing with Jasmine, Jest, and vtest, is hard. There are many tools out there. The one that I would recommend is Spectator. Another one, which is also very popular, also very powerful, is Spectator. This is the testing library, sorry. So I want to say the one that I would recommend is the testing library, but Spectator is also a very powerful one. So I would say you have to choose when it comes to component integration testing between these three. It's Cypress, it's Playwright, both component tester, or just Jasmine Jest with retest, but then with the testing library. And then again, what are the advantages? Why should I choose one over the other? The testing library, it's of course much better than using the native test bed. It really makes your testing experience, developer experience, very good. It also enforces a certain testing style. It says you always go via the DOM. You can also go via the TypeScript class if you want to, but then you don't get any support from the testing library. So it really tries to give you a guideline on how to select things and also how to communicate with your component. It has a huge ecosystem. The testing library is not just available for Angular. It was actually made for React. We have bindings for React. We have bindings for Vue. We have also bindings for Cypress, for example. And of course, if you have such a huge ecosystem, it's obvious that you have also a lot of plugins. And of course, you can then use Jasmine Jest, whatever you have. You don't need to switch the technology. You don't need to switch the testing framework. That's a good thing. But you don't reach that amount of developer experience that you get with an end-to-end testing framework. Because with an end-to-end testing framework, you really see what you're doing. You see the browser. Yeah, it's just much better. Cypress component testing, quickly, wonderful developer experience integrated into Angular. And of course, you also have lower maintenance costs because, yeah, the testing code is just a small part of that part that you have, even if you are using the testing library. Some drawbacks about Cypress component testing, there are some as well. Again, this kind of minor constraints which you might have. We hear issues when it comes with the build time, memory issues with larger projects, obviously. And then we have this not actively maintained. And I make this quick because there we have to be a little bit careful when I say Cypress component testing for Angular is not actively maintained. There was a GitHub issue where Cypress wanted to reach out to the Angular community. They asked, what can we do? What do you need from us in order to support Angular better? This issue was open, I think, more than half a year. As far as I know, only 1 or 2 persons answered. I was one among them. And since then, we didn't see any development in component testing for Angular anymore. And the last release was March last year. So it's already more than a year old. With Playwright, this is brand new. The PR is more or less ready. It still has to be merged. But with Playwright, we have the same advantages that we have with Cypress, but Playwright is very community driven. So where Cypress said, Cypress itself, we want to support Angular. In Playwright, it was different. Playwright said, we have a component tester, but then it was members of the community, and they are Yunus Chahidi and Sander. I only know his GitHub nickname, but these two are the leading figures behind it. And we could not say we have now also support for Playwright as well. We will see how this turns out in the future, but it's highly experimental. So Playwright marks its component tester experimental. It looks very promising. And yeah, we will see how this now evolves when the first release is there, but it looks very good. And in the end, I'm already finished more or less with my presentation. So this was the overlook of the tools. You should now know enough what you can expect in the future. You should know about the disadvantage, the advantages of these testing tools. You need to choose. If you ask me, I would say I'm brave. I would go with Playwright component testing at the moment. If I start with a new project, and I would also pick Jasmine at the moment because that's the one which is supported by Angular. And for me, it just works fine. Works well. But in the end, it's your choice. Good. Here you have further readings. I will post my slides later. So you have some about theory and so on and so forth. But that's it. Thank you very much. And yeah, enjoy the rest of the conference.
Yeah. Thank you very much, Rainer. This was a really interesting talk. And
Thanks.
Yeah, thank you for letting us know about the tests.
So, yeah, thank you. Thank you. You're welcome.
Thank you very much. So now we go to the next talk. This is also very interesting. So it's how to cut our tasks into pieces. So Julian, he's based in Vienna in Austria, and he's a very accomplished front-end engineer, trainer, and consultant, and he's specializing in Angular and web performance optimization. So yeah, Julian, join us on the stage.
Hello, welcome everyone. Thanks for the introduction, Ahmed.
You're welcome. Yeah. So now you can start. You can share your screen, and I will go away.
Okay, perfect. So stage is already mine.
Yes, exactly.
Perfect. Let me quickly share my screen here. Very good. Okay. So welcome everyone to my talk, Cut My Task into Pieces. This is concurrent mode. This talk will be, of course, about web performance, and we apply all the strategies we learn here on Angular. Thus, all the knowledge I will share here is also applicable for essentially every JavaScript application, even Node applications. So we will go into a deep dive about INP, about JavaScript runtime performance. So without further ado, let's go straight into it. So what happens when a user interacts with your application? So imagine some user clicks a button in your app or resizes the window or navigates around with the keyboard. What the browser internally does is it will create a task for you. So the task is here in order to execute all the JavaScript you have assigned to that very event binding. So this is any discrete piece of work that the browser does at one single point of time. And let's break it down a little bit. So in the very top, we see, like in the yellow color, we see the browser event that's kicking off. In this case, it was a click event. Then below, in some random other color, you see the application code that is actually assigned, like most of the time written by yourself, to this event binding, and then it's getting executed. And in the end, most of the time in the end, you will see the rendering and the painting phase here in purple and in the green colors. There's also, besides just tasks, there are also long tasks. So long task is any task that is exceeding the 50 millisecond processing time threshold. So in this very case, we have a blocking time. So the red shifted area here at the top right is indicating the area that is considered as blocking time. So 14.9 milliseconds are here the blocking time, because this is the time we exceed the 50 millisecond threshold until a task is considered as a long task. Looks scary, right? But why should you even care about that? So there's this new beautiful metric. It's a core Web Vital now, which is called INP, Interaction to Next Paint. It replaced first input delay at the 12th of March this year, so it's not long ago. And you want to take care about that this metric is in a good place, because this is actually indicating how fast and how snappy your application is responding to user inputs. And as you can see, you have only a limit of 200 milliseconds until your browser starts to consider it not being good anymore. So let's break INP a little bit down. INP is divided in 3 different phases. So we have the input delay here in the very beginning. So the time it takes until the browser can finally process whatever interaction it wanted to kick off now. Then you have the processing time, so the time it took to actually process this event binding. And then in the end, the presentation delay, which would be the rendering, the style recalculation, and the painting phase. And all of this together will be your INP value that is coming out of this. So before we go into any demo, let me quickly introduce myself. Hey, my name is Julian Jandl. I'm performance engineer, trainer, and consultant at the company Pushbase. And I'm also RX Angular core maintainer, which is kind of important for this talk. So let's go into a live demo and let's take a look at how long tasks and INP are looking. So I've prepared this demo application here where you right now see a blank page. On the right side, I have my DevTools open, and I've filtered here for vitals. And this is essential because I've installed a extension that prints out core web vitals to me whenever I interact with the page or when I refresh the page. So let's click on the native button here and let's see what is getting rendered. So we see it's we get an application, a demo application rendered with a header bar, a sidebar, a content with a list, and a footer. And here on the right side in the console, I can see interaction. So 296 milliseconds needs improvement. So this would be now my INP value. And if I go here and throttle my CPU a little bit, because my machine is a little bit faster than most mobile phones at least. So let's refresh the page, clear the console, and go back to the native route. And now we see an INP value here of over 1 second. And this is the stuff we definitely want to fix here. So now you have seen how long tasks can affect the INP, because we render all of our content at once, and the content tends to be heavy in this case. And this is causing very high INP values. So what options do we have in order to improve this? We can be smart about it, and we can say, yeah, we schedule that thing. So what kind of scheduling techniques do we have in order to fix it? So we could use the timer API, so any set timeout or set interval. We could use the request idle callback. There's also the message channel API, which is usually used to communicate between different browser tabs, but we can also use it in order to schedule our work. We can also use the request animation frame API or the new scheduler.postTask. But whatever API we choose, in the end, what we want to is we want this very long task that is executed here, which is causing a high INP value, to just be a very tiny task, to have a very good INP metric, and schedule our big work again, like into the future, and we have a good INP metric and we don't care about it anymore. So let's try this. We go back to the demo application, and I will do a quick refresh here. And let me hit now the button that says schedule, because this is where I actually implemented that. And I can also show you the code real quick. So if I go to the main application, the default routing to the native route was just done by a router link. And here, in order to route to the scheduled route, I have a custom click binding assigned here, which just says set timer, set timeout, this router.navigate. So what should happen now is, when I click this button here, the interaction should be super fast and the long task should be in a scheduled piece of work. So let's click it. And as we can see, our interaction time, or the INP value that is being printed out here, is now 32 milliseconds. So this is quite of an improvement, and I still have the throttling enabled. And just for reference, let me go to the native route again. Now we see it's over a second. So we definitely cheated the INP metric here by just scheduling away that piece of work to a future point in time. So let's go back to the slides. And now we can conclude here, yes, this works. But what happens if in the middle of this super long task, like remember, we schedule a 1 second task here into the future, what happens if we again interact with the application while this task is being executed? Well, I kind of have the feeling that there is a big elephant in the room. So let's break it down a little bit to make the elephant even more visible than just standing in the middle of the room. So what's happening here is, when we interact in the middle of a blocking task, we will just have a super large input delay for any future task we actually want to interact, because the browser cannot execute multiple tasks at once. It has to wait until the first task that we've scheduled is finished until it can process any new event coming in. So again, we might improve the immediate INP just if you are a very behaving user and you click and then you wait. But if you do anything in between, it will mess up your INP again. So why is this the case? Let's discuss the event loop a little bit. So within the JavaScript ecosystem, so in the virtual machine, we have just a endless loop going on, which says queue, wait for message. So while we have any message to process, just process it. And this queue that is iterated over here is the so-called macro task queue. And the macro task queue is nothing else than a queue of tasks that the browser has to process one after another. So let's take a look at what APIs calls a new macro task on this queue. So we have all of the timer APIs that we've discussed before. So timer, idle callback, message channel, request animation frame. Then on top of it, any browser event you can think of. So any click, drag, resize, HTTP response, or any other thing that the user can do with your browser. And of course, there's even more, because also third-party extensions run on your main thread, and they also cause macro tasks to happen. So in the end, the full picture of the event loop would be just an endless loop over the macro task queue that runs with the run to completion model. So what does that mean now? Before we can process, in this case, the click event that is next up in our queue, we have to finish our mouse down event. So let's take a look at what happens in our mouse down event. So within our mouse down event handler, we have two pieces of work being executed, one function that is called work, another function that is called work2. And then we can see here in the execution flame chart of this task, we can see first work is being executed, then work2 is getting executed. And when this is finished, the browser can start executing the click event, where we say, do something on click. So again, the browser spawns a new task, not this time for the click event listener, and it executes the function callbacks assigned to this event. And in the end, we want to wait for our timer fired. And this is now the example we had before. We had our click event, very good INP, scheduled away some big long task in a timer, and now we receive an input in the middle of this event. So of course, the browser adds the new event click to the macro task queue, but because of the run to completion event, it cannot execute the click right away. It has to wait until the timer fired is being fully executed. And this is causing high input delay for the next INP. So again, this is the full picture of the INP when we interact within a blocking task. So let's go into a demo about this as well. Let me do a full refresh here. And this time around, I think we have enough time today to do some flame chart analysis live. So this time around, I want to go to the scheduled route. And while the long task is being executed, I will again interact with the application. So let me click now, and then I click a couple of more times. And now you see here all the metrics being sent here. So this would be the long INP, would be my very first click to the scheduled route. Let's break it down. So you can see here, that was the very first, the very first click, of course, was the good one because we scheduled away. The second one, we clicked in the middle of header bar. The third one is the same. Then we have again in the middle of header bar because I clicked in the very same sections here. But as you can see now, if I expand this, we can see it's telling me, let me expand this, and the event timing. And here we can tell for the duration, we can also say processing end, processing start, and the start time. But what I was looking for was actually the input delay, which it should print out as well in this case. So let me figure out if I find an event here that gives me the input delay. Ah, yes, input delay, of course. Here in the table, we find as a first entry the input delay of 500 milliseconds. So for this, it's the same 700 milliseconds as an input delay because we were executing something in the middle of something else was being executed. So let's make a flame chart recording of this while I do the same thing, and then we can see how this is recorded. So I start the recording here now, click on scheduled and click in the middle, just a little bit around, stop the profiler. And now we can see here our big long task is being executed. So here we see the click event listener with our first pointer event being recorded. So this is the good INP we have cheated in now. Then we see this big long task that is the work we've actually scheduled away with our set timeout call. And here we see at this point in time here, like after, we can measure it, let's say after 200 milliseconds, I clicked again, and it is starting to record here. And we can see here now input delay of 1 second. So this bar, which starts here and ends here at the execution time, is our input delay indication. And here we see all the other pointer events that happened in between I was recording here. So yeah, you can see the long task is blocking the main thread here, and you can see also that the click event listener that I've spawned afterwards is executed only after this amount of time here, because we were executing this piece of work here. Okay, let's go back to the slides now. So the question would be, now we know long tasks are doing bad things to our UX and bad things to our INP values. So what to do with the long task then? My good friend Kirill actually suggested a very nice game to play here in order to get rid of all the long tasks. But unfortunately, this is not really working out in the real world. So let's discuss the things that we can actually do. So in our opinion, there are 3 ways to improve long tasks. The first, and of course, always preferred solution, would be to reduce the amount of work that you are doing. So whenever you see, okay, there's something executed that we just don't need to execute at all, just get rid of it. Or if you have a very badly implemented algorithm, so you can improve it, also very good. But in reality, in most cases, this is not really working out. It's not feasible. It's also mostly connected with very high effort. So let's consider the other 2 things we can do. We can distribute the piece of work. So we have a very big chunk of work, and we can just slice it up into smaller chunks and then distribute them on the main thread. And lastly, and this is a little bit connected to the distribution, is we can prioritize the work. So after we have sliced it up, we can say, okay, some things are more important than other things, so let's execute the more important things first. And this is where I need to introduce you to the RX Angular concurrent mode. So this is part of our open source library, where we actually implement the latter 2 concepts, like the distribution and the prioritization. So we have 4 concepts involved here in order to implement the prioritization and the distribution. So we have scheduling. We already know how scheduling works and what it does. We have chunking, so slicing the big piece of work that is left over that we have scheduled into smaller consumable chunks. Then we have the concept of the frame budget. So you as a developer can decide at what FPS your application should render, and like this is how you can determine the size of the chunks you create. And then in the end, of course, we have the priority, so how you can prioritize work that is being scheduled. So the first concept would be scheduling. As I said before, we are already aware about this technique, so we just install some timer or any other scheduling technique to schedule something into the future. Then we have chunking, so slicing the one big piece into smaller chunks. Because when we do that, we give the browser the chance to react in between to new user input, thus, of course, positively impacting your INP metric. So given the example we have seen before, where we have the header, the sidebar, the content, and the footer in our template, what we want to do is, or what we have right now, is we render everything at once, right? So we click, we render the new component, then we render header, sidebar, body, footer, whatever is inside. We need to render it immediately before we can paint the next picture. So what if we can just slice it on a per component basis, like on the template level? Slice the header from the sidebar, from the body, from the footer. And then execute them one by one. You can do that very simply by just using the rx-let directive from the add-rx-angular template package. We can just assign the rx-let with an empty input here. Of course, in a real-world application, you would probably assign some reactive state here, but for this case, we just want to schedule it, so we just give it an empty input. So we assign the rx-let structural directive for each section of our template, for the header, the sidebar, the body, and the footer. And what it will do, it will create one slice of work for each part of the template. You might have noticed that in the body section, we also have lists. So we can not only slice those big chunks of templates, we can also apply this technique to lists. Because lists is in case you didn't know, in most cases, at least at Bootstrap performance, so when you switch route, also on soft navigations, one major culprit for good IMP values, because in most of the time you render way too many elements at once, or you have to render many elements at once. So what we can do here, instead of using the default ng4 or the new control flow, we can use the rx4 implementation from also the Rx Angular template package. So this is how you can use it. It's just a drop-in replacement. It's behaving and taking the very same inputs as ng4, and what it will do, it will slice up your template into smaller pieces, so for list items. But of course, it's not as stupid as cutting each iterated view into one slice, because this would create very much overhead. Instead, we have the frame budget concept. So we can configure, for example, 30 FPS, which would mean we have 33 milliseconds for each task. So we have kind of big chunks. We can configure it, and this is, by the way, the default, to 60 FPS, so we have 16 milliseconds per task. Or we can go all the way up for 90 FPS, so we have 11 milliseconds per task. So it tries to gather everything that fits into this frame budget before scheduling a new task. So how does this work? Imagine we have configured 60 FPS, so the default. It creates one item and sees, okay, it's only took 4 milliseconds. No problem, we can create the next view. And we can create the next view. And now we can still create the next view because we didn't hit the threshold. So we will create it, and now we see, okay, we now are over threshold. So what we will do now is whatever is now also scheduled for the future has to wait until we tick once, let the browser render, re-interact to users, and then we render everything else and repeat this. So again, we have a while loop internally running, so that asks for while we have a task, and while the current runtime is below the configured threshold, get the new task, and then execute it and account for the time and add it up to the runtime so that we can compare it again to the threshold. Let's take a look at how this looks like. Okay, I've still, as you can see here by the warning sign, I've still throttled my browser, and I can go here now and do a small refresh. Let's take a look. Yes, everything is refreshed. And now I have this route here that is called concurrent. And before I will click it, let's quickly go into the code, how this is looking like. So I will go to the concurrent component now. And as I have shown you before in the slides, just instead of rendering header bar, sidebar, main content, and footer bar as they were, instead we will use the rx-let directive with an empty input here on top. So let's see what this is doing. Maybe you can even visually telling without me measuring anything. So I click it here now, and now you can see we have very good IMP value of 80 milliseconds. We rendered the header bar, then the sidebar, then the content, and then the footer. So let's go back to the blank page here. Let's do a quick performance measurement of this. Okay, it's rendering. Stop the profiler, and let's dive into what's happening here. So now what we can see here is all those chunks are getting executed. So chunk number 1, chunk number 2, chunk number 3, rather big, like 700 milliseconds, and chunk number 4. So those should be now our chunks of the template. We can also follow them here in the screenshot section. So header bar, then content takes a little while until it kicks in, and then we in the end see the footer being added as well. So we can also see this here by name. So header work is being executed, then sidebar work, then we see the content work, and directly connected to the content work, we see all those list item work here. So this might be the ng4 that is still in place, that's rendering all the list items at once. And then we see the footer here in the end. So let's go back to our to the app code and replace ng4 now with rx4, because I said we can do the same thing also for lists. So let me do a quick fresh state. Very good. And now I will click the concurrent button, and you can see now first header bar, then sidebar, then the content, then the footer edit. And in the middle of the process, you could see that this list here is growing. Let me do that again. Up. All the items were added here, like we have 100 items. So let's take a look at the flame charts now. Okay. So now we can see also in the screenshot section, we start with like 2 items here and then render 2, 3, 4, 5, 6, 10, and the rest of the items are following. So now we don't have this 700 millisecond blocking task in the middle of nowhere here anymore. So we see header, sidebar, then content, then the footer, but the actual items here are rendered here as a per chunk. Here we can see what's going on here. This is RX4 doing its job, so rendering all the items at once. And here you can see it's actually, because the work is not too heavy at once, it actually respects the 16 millisecond threshold as good as it can. So most of the tasks are actually within this budget we have configured before. So let's take a look quickly at what we have achieved, because now I can switch back between blank and concurrent without having very bad INP values in between. So as you can see, I can immediately interrupt the process without having any issues whatsoever, because we don't have to wait until the full picture is fully rendered. We can immediately abort the process because we have chunked it up into smaller slices. Of course, we still see some bad INP values here with probably input delay, yes, with high input delay being at 200 milliseconds. Yeah, because if we take a look at this at the flame charts again, we have still 200 milliseconds of work packages here, because the work function that is getting executed here to make it artificially bad is just a big chunk of work. So this is still the reason. So if you want to further improve, we wanted to chunk down or improve this work function here. So the final piece that is missing here is the prioritization. We did a very good job until now for the distribution part. We chunked everything up into smaller pieces and rendered them bit by bit. But right now we started with header bar, then sidebar, then body, then footer. And maybe we want to emphasize the body a little bit more and render this instead as the first piece. So having body, then sidebar, because those are the more important pieces, then header, and then the footer. So we want to switch priorities here a little bit, because right now the priority is depending in the order of the template where you configured it. So in the RX Angular concurrent mode, you have 5 different priorities you can assign here. You have the immediate priority, which would be highest, then user blocking, normal, which is the default priority, which is assigned if you do not do anything, then the low priority, and lastly, the idle priority. So in order to achieve the goal of having content first and then the sidebar, then the header, then the footer, what we can do is just assign a lower strategy for the header and the footer and a higher strategy for the body. That would be totally sufficient in order to do that. Of course, there would be other combinations that also work out. So let's do a quick live demo about that as well. So first, before we go into the application itself, let's dive into the code a little bit. So let me go to concurrent priority component. So the last section of our demo here, where we have the empty input again, and then as an input value for strategy, we assign just low for the header bar, and for the footer bar as well, we assign the low strategy, and for the main content, we assign the immediate strategy. So let's take a look at what's happening now, or let's first recap what happened before, just visually. We click concurrent, so we see header, sidebar, content, footer. And now we click concurrent prioritized, where we see first content, then sidebar, then header, then footer. So this would be the result I actually would want to see, because the content would be, in my opinion, the most important part of this application. So I want to display it first. And of course, now I can switch around those 2 tabs here freely without being interrupted, even with 4 times throttling enabled. Okay, so I start to wrap up things now. So this was the introduction to the RX Angular concurrent mode. And if you have liked what you have seen, then please check it out, start us on GitHub, and maybe you just want to try it out and play around and fix the INP problems of your applications with it. I want to give a shout out again to my good friend Kirill, who wrote this masterpiece, Mastering Interaction to Next Paint with RX Angular. You get very good information here about INP in general, about core web vitals, about scheduling techniques, and a little bit of RX Angular as well in the end. So make sure to give that a read as well. Again, my name is Julian Jandl. I'm performance engineer, trainer, and consultant at the company Pushbased. And thank you for your precious time. If you want to have access to the slides or to the repository, make sure to make a screenshot now, because this is an online conference, or I will share it afterwards on Twitter anyway, so make sure to follow. And that's about it. Thank you for your attention. Thank you for your time.
Thank you very much, Julian. Yeah, it was a good talk, and for sure I will try it out after we finish it. So
yeah, give me
thank you very much again.
Feedback.
Yeah, sure, I will. I will.
Amazing.
Thank you very much, Julian.
Thank you too.
Okay.
Goodbye.
Thank you. Bye-bye. Okay, so now for our next talk. Yeah, we have Esse, your front-end developer at Profitable, who loves building cool things. So she will show us today what is the sweet spots for our progressive web apps. So Esse, you are now on stage. Hi, Esse.
I am Ed. Hi everyone. Thanks for having me. Okay, can you hear me?
I will share the screen. Yeah, we can hear you, and now your screen also is shared. So your stage is all yours. Thank you.
Okay, perfect. So hi everyone. My name is Esse Monday, and I'm a front-end engineer. I've been a front-end engineer for the past 5 years, and my topic is on progressive web app, the sweet spots. So over the past 5 years, I've been building applications, and I think we've mostly been building applications based on building a website, or you want to build a native application. And most times I feel like having both of them separate does not just get you what you want. Like sometimes you want to build a native application, but then you want the SEO of a website, and that is where the progressive web application comes in. So a little bit about me. I'm a front-end engineer. I've been focused on the front end for the past 5 years. And in my spare time, I love to play video games and spend time with my family. And I have 2 amazing dogs. I love dogs. I have a Caucasian Shepherd, and then I have a Lhasa Apso. And then my favorite quote is chase excellence and success will follow pants down. So if you're familiar with that quote, it's from the movie Three Idiots. It's been one of my go-to quotes whenever I feel down. So let's dive right in. So this is what we're talking about today. We'll be talking about the limitations of websites, the limitations of native applications, and then we'll be talking about the progressive web application, the sweet spot, like what it actually gives you. It gives you the best of both worlds, both websites and both native application. And then we'll be talking about the benefits, and then we'll be looking at a real world case study. So when it comes to websites, hello, I don't know. Okay, I think when it comes to websites, one of the major pitfalls that we always encounter is performance. If you've been a developer for years, you would notice the one major thing we've always had issues with is performance. The more images you add, or the more styling you add, or the more JavaScript you add to your application with poor internet connection. And then also another issue what we always encounter is the issue of functionality. Some applications you build might be more compatible on a Firefox browser, and the moment you move it down to a Chrome browser, you start having some performance issue. And also something we also have is the user experience. Um, as a rule of thumb, we're always told to build mobile first, but most times I think we end up building for desktop first, and then even if we build for the mobile first, we don't consider very big applications. Like one of my takes on the CES 2024 that just happened was that there are going to be larger screens, and we're going to have to focus on targeting those screens. And then also another pitfall of websites is the offline functionality. The moment your end user, the moment their internet connection is not so stable, we start having a lot of performance issues. And then that is it for the limitation of websites. Then when we come to native applications, one of the major pitfalls of native applications is that it requires your user to always download. So for every new version of your application you put to the App Store, they always have to go and then download. And I feel like that's in itself kills the user experience. If as an end user I just want to come, I want to be able to use your application. I don't want to have to bother about okay whether it's up to date or not. And then once and on that thing is the more upgrades you build to your applications, the more it might not be so backward compatible. And then on that thing is native applications are always very, very expensive to develop. They're expensive to develop, they're expensive to maintain. And then whenever you want to push an update to your native application on the Play Store, say on the Play Store or the App Store, your users always have to download, they always have to install. And I feel like having your application on the Play Store, you don't really get to tap into SEO, that's search engine optimization, because it's hosted on Google Play Store or Apple App Store. So it doesn't have that much reach as you would have with your websites. So I think that is where progressive web applications come in. So progressive applications, they are web applications that leverage both web development, and then they also leverage the native feeling of mobile applications, of your Android applications and your Apple applications on your phone. So I think for this, okay, okay. So for the progressive web application, okay, for progressive web applications, they leverage both the modern web application, and then they also leverage Android applications. That's the native feeling of it. And one of the good things you get from progressive web applications is push notification, and then it also allows you cater for offline functionality. So when it comes to building the progressive web application, from the word progressive web application, that means you are moving beyond just the native web application we're used to. So we're moving we're taking it a step forward. And one of the three files you will need to build a progressive web application is your manifest file, your service worker, and then also your offline page, which is the page you want to show to the user when the application is not available, or probably some internet connection error. And the backbone or the brain behind progressive web application is the service worker. And then what is a service worker? Sorry, I think it skipped so fast. So your service worker. So basically, a service worker is like an intermediary between your server, your network, or the browser. That's the client application. So whenever your user makes a request to say loads the home page, the service worker comes in between, and it kind of caches the response from the server and then saves it, so that whenever your application goes offline and the server is not responsive, it kind of returns the response from the cache already saved in the client's browser. And I think I'll be illustrating that. I think I already have an application built for that, and we'll be illustrating that. So, and I think a common example of a progressive web application is the Twitter Lights. I don't know if anyone has had the opportunity to use it. It's kind of buttresses the point of progressive web applications. So I think I have a React application already built, and I'll be showing you the difference between having how you convert it from a progressive web application and just having a website. So So if you give me a moment. Yes. Okay, I don't know if you can see my screen.
Yes, you can see your screen, but it's still the slides.
I don't
So
know if
do
you
you
can
share
see my
another
screen. I don't
screen
know.
or?
Yeah, I'm trying to share my screen. Okay, I think it's sharing now. Oh yes,
Yes, now it's Visual Studio
perfect.
Code. Yeah.
It's sharing now. Okay, perfect. So this is a sample application I already built. It's a simple weather application, and I already have it running here. So this is just a simple web application. It doesn't do much. It doesn't do much. It just fetches data from an API and then displays the data. Okay. Okay, so this is it. It's a basic weather application. It doesn't do much. All it does is fetches the data from an API and it just displays it on the front end. There's nothing too complicated here. But if I was to go and inspect this web application and I trigger an offline functionality for it, like currently now, if I reload it, it still shows something. What I'm trying to show how the progress web application works. Like this, it works fine. There's no service worker. I've not included service worker.
So guys, I think there's a problem in the network. So yeah, we're trying to reconnect now. Just give us a few minutes. Okay, guys, so we are back now. S is back, so please, your stage is yours again.
Hi, sorry for the interruption. Ah, think okay. I think we can continue from where we
So
stopped.
now
I was trying to
you're
illustrate
yeah.
how the service worker works. So that's your progressive web app is or works offline. So like I was saying, this is a basic React application. It doesn't do much. All it does is it fetches data from a server and then displays the data. So this is my application working online. This is my application when it works online. And if I was to take it offline, nothing would show still. So this is my application online, and I just triggered the offline functionality. It's already said telling me network error. So if I was to reload the application, just because I am not online, I would not have anything. I would not get any feedback. All I would get is a broken website. But if I was to introduce a service worker to handle at this point where my server is no longer available, I already created a sample service worker. It's a simple JavaScript file that directs the network request from the clients to the server. And I think I have it here. My service worker file saved here. It's always saved in the public for script file. It just what this does is it installs it and then it tells what I'm telling it to do is okay, cache all of these routes and save it in the client's browser so that whenever my application is offline, the user still gets to interact with my application still. So if I was to introduce myself, so now this is my application with the service worker. Give it a moment to compile. Okay, safely compiled. Now let's try this again. Now I go back online. I come to the application, check the storage, clear out the site data, then I reload it. Now this is my application online. It works as usual. Nothing, it works as usual. But then there's a difference. If you come to the service worker tab, or say here. So what just happened is when I made the request to the service worker acted in the middle and then saved some data to the client's browser so that whenever my server is down and whenever there's a network connection error, my application can still be accessible. So if I was to come here and say, and I trigger the offline functionality for my application and I try to reload this. And I try to reload it. This where's my slide? I think here's my slide. If you've ever used Twitter Lite, you would notice that you can actually save, you can save and download your application, your web application, like an Android application. Okay, yes. I think this is okay, yes. So this is it. Whenever you have a progressive web application, you can also save it. You can download it, but then okay. So whenever you have a progressive web application, it can also be saved to your home screen, just like you have your Android application. And I think that is the power of a service worker. I don't know if there are any questions.
So yeah, thank you very much, Issa. I think we didn't get any questions in the chat here. So thank you very much for the talk. It was really useful for understanding PWA. So
Hi,
thanks a lot.
Ahmed.
Yeah, can you hear me, Issa? Hello? Okay, I think Issa is not hearing us. So, Issa, can you hear us?
I can hear you.
Okay. So I'm saying thank you very much for this talk. It was really good. So will
Hello?
you get any
Can you hear me?
question? Yeah, we can hear you. Yes, sir? We can hear you very good.
Okay, thanks for having me.
Yeah, thank you very much.
Thanks for having me.
Thanks a lot for you. And yeah, now we go to our next talk. So yeah, so our next talk will be island architecture. So Olaboda will explain to us what is an island architecture. So it's a recipe for modern web performance optimization. So he's a software engineer. He's deeply passionate about open source software. And yeah, let's get him on stage now so he can explain to us more. Hello. Hi, Ola. You are now on stage. I hope I was saying your name correctly. So I'm sorry if I said it wrong.
It's all right. It's all right. I'll take it that way.
Yeah.
You can just put simply like
Yeah,
Ola. Ola
Ola.
is
Okay,
being simple.
good.
Yes, that's great. Can you hear
Okay,
me?
perfect.
Like very audibly.
Yeah, we can. Yeah, we can hear you very good.
All right, cool.
So
Thank you very much.
now is stage is yours, so you can share your screen, and I will add it directly now.
Share screen. Share screen. Entire screen. Okay, cool. Just one moment.
Sorry.
How about now?
Okay, so
Can you see my screen?
now you're yes. Now
Alright,
your
cool.
screen is there, and yeah. Okay, stage is yours.
All right, thank you very much. Start. Hi, everyone. My name is Alabadila Shidobe. I'm a software engineer and a super crazy open source enthusiast and advocate. You will find me talking open source everywhere I go to. It's not my fault. I just like that thing. Allow me, it's my first time speaking, and it's truly an honor to share the virtual stage with such a great lineup of speakers. Without further ado, I will just go on and dive right into this, and I hope you enjoyed this talk as much as I did making it, right? So we're going to be talking about islands architecture today and how it can be a great recipe for performance optimization on this modern day web, right? So performance is what I'm going to obviously start with, right? And performance, it's something that is on everyone's lip, regardless of your background, regardless of the language that you speak. Performance is a super important architectural criteria for any innovation that we're building these days, especially when you're building on the web. performance is super important, right? And one other thing that comes to mind when you talk about important and talk about the web is JavaScript. JavaScript is super important. We can nearly almost not do without it. We just can't do without it to a certain extent, right? But JavaScript as is can be a crook, can be super crazy sometimes. And it can just go on and cause a lot of hurt to performance on the web. JavaScript is important, performance is important, and JavaScript can be a crook and cause performance a lot of hurt on the web. And it's important to state that the only time JavaScript behaves this way is when it's too much. So it means that when JavaScript is too much on the web, JavaScript is a demon, right? But anyway, I've got something I want to show you when we talk about performance. So here's a website that I created some years ago. I just learned the Meta framework at the time, and I just learned TIL and CSS too at the time. So this was one of the very few projects that I created to sort of show my skill, right? So here's a website, super performant, right? If I give you this URL and you load it on your machine, your high-end machine, obviously, your super fast computer, your PC or your Mac, it will actually perform well, and that's good for performance, right? But performance isn't just high-end machine. What does it perform like on low-end machine, right? So here's me putting the website to a test with a throttled network, low performance machine, and 2G internet, very slow, right? So we can see here that we're currently loading the website, and we are already on the 6-second mark, going already to 10 seconds. And here we are still presented with a white screen. Nothing is really making sense on the web page right now. And we're still going to about 20 seconds at the moment. We're still not presented with anything on the screen that makes sense. Oh, finally, at 23, 24 seconds, we got presented with something, just something, right? And this something, as far as I'm concerned, doesn't make any sense yet. You cannot exactly interact with this. Nothing that you will click for interactivity at the moment will work, right? And this goes on and on. We're already on the 41-second mark. This continues to go on for a very long time. And I think it took about almost 2 minutes before we got to something that makes sense. Now we see most of the pages, content and stuff, and maybe now we can interact. Now I've had to wait for 2 minutes. So I did a performance test on this website, and here's what I got. I did this performance test with Lighthouse, and this is the best results on that throttled network, right? You see here that we took about a combination of this 13 seconds plus 19 seconds to paint a content on our page that makes sense. And we still took about 13 to about this amount of seconds to sort of paint something that sort of maybe makes sense a little bit again that we can interact with, right? This is really bad, right? Very, very bad. So I just want to say this now. Can you relate to this? Can you relate to a situation where, have you ever been faced by this situation whereby you load the website, or just like we see, you load the website and you just stay staring at a white screen for a very long time before you get presented with a certain content that you can interact with? If you've seen that, that is what they call bad FMP. FMP means first meaningful paint, and that is a metric that determines how long it takes for a website that you load on your computer or your phone to present you with a content that you can interact with, right? Have you ever experienced this situation too, whereby you load the website and you get all the content that you can interact with, but then there's a certain component within that website, maybe a form or a button that you want to click and do something with immediately, but then it's just not responding. You click it multiple times, it's just not responding. That is what you call a slow TTI. So slow TTI means time to interact, right? And time to interact is the metric that calculates how long it takes for content that you get when you visit a website, how long it takes for that content to become interactive for you to use it, for it to be useful to you, right? So that website I just showed you really performed badly, right? But then what we're going to be talking about today is island architecture, and I've just gone on to correct my mistake by recreating that website. I've redeployed it on a new URL, and here is me putting that new deployment to the same test on the same throttle network that I did put the initial one, right? So as we can see here, on the very first second, the third second to the fourth second, before the 6th second, we already got the initial paint. This took about 20 seconds for the initial one, right? And by the time we got to the 11 seconds, 12 seconds, we already got paint that makes sense, that is almost ready for us to interact with, right? And this went on for not very long. Before we got to the 30 seconds mark, now we got like meaningful pain that we can obviously interact with. So just relish that. See how great that is. So I went on and did a performance test for that, right? And this is the best result we improvement, like from 25 to 85. Now we've got like 1 to 2, 3 seconds. We've got about 2 seconds for us to, like be able to interact quickly with the content that, like was painted on the page. This is really nice, right? Yes, for sure. I think you like it. Well, anyway, the course of this presentation, I will be discussing a lot of hows, right? And one of the hows I will be discussing is how to take your website or any web application, that one that was performing so badly, to something that performs way better, that you can see, right? That performs well on all devices. I will also talk about how JavaScript managed to, like hinder performance to some certain extent, right? And I'll also talk about how this will be me talking in my defense though. I will talk about how I managed to develop such a bad performing website, right? And I'll also talk about how far we've come to conclude that islands architecture is one of the ways to go for you to improve performance on the web. And in my defense, I will start with that. In my defense, like I said, I want to talk about how I managed to create such a bad performing website, right? But that can be associated to how we currently build on the web, because I told you I just developed that website not too long ago, right? So the way we currently build on the web these days, you'd see us consume meta frameworks like React, Vue, Angular, Svelte. You'd see us develop websites with this application and this libraries or meta framework that we call them, right? And one thing this meta framework have in common is they heat, sleep, breathe a lot of JavaScript, right? And JavaScript is something we complain now that if it's too much on the web, it hinders performance, right? But that really gets me to ask a certain question. How much JavaScript do we really need to not affect performance, right? So I've just gone on and did some research. I created this chart to sort of like categorize a list of websites, a list of category of website that you might want to build and the kind of JavaScript that you will obviously be needing just to, like get them be very good for performance on all devices, right? So I've come up with a list. I think if you're building blogs or doc sites, you need almost zero JavaScript. But if you're building a doc site that has like a code snippet, like the code preview kind of thing on there, maybe you do need some JavaScript. So if you're building a marketing website, e-commerce or landing pages, you need some JavaScript. If you're building SaaS products or you're building the super crazy web-based application that are super interactive, you need plenty JavaScript for that, right? But then now we know how many JavaScript that we need. But if we take that amount of JavaScript that we need as expected and then compare what we currently build with these days, and then compare how we build to the amount of JavaScript that stuff that we currently build these days, the amount of JavaScript that they end up shipping to the browser for us, right? When I look at that, building with the current meta frameworks that we build, I've realized that we actually end up shipping almost the same amount of JavaScript if you're expecting some level of JavaScript or if you're expecting a lot of JavaScript, right? We end up shipping almost the same amount of JavaScript, right? So in the case where you're expecting a lot of JavaScript, because you're building really high-end application on the web, that is cool, right? It's cool. But in cases where you are just building to get some amount of JavaScript just to power interactivity on your website, that is not cool at all. I mean, like, it's not cool. Thumbs down, big time, right? But the thing is, we're building with these meta frameworks and they're shipping this amount of JavaScript, right? Are we then going to pass on the blame to the meta frameworks for being the reason why we're shipping that much JavaScript and building bad performing websites or web applications on the web? I don't think that is nice. We cannot exactly do that. Reason why that is the case is because that is how this meta framework roll. That's how they work. They need this JavaScript to do a lot of stuff like rendering the web page, adding interactivity to the web page, creating navigation, managing states, and a lot of stuff. And they need a lot of JavaScript for that, right? But then we want to build with this meta framework. We don't want to ship a lot of JavaScript, right? We don't want to ship a lot of JavaScript. What then is the solution? That is where Islands architecture comes in, right? And as you can see me demo in the first place, saw what happened with what I said I did with Islands architecture, that really seemed like the way to go, right? But what is Islands architecture? Island architecture is a methodology that was made popular by these two great folks, right? It's a paradigm that aims to reduce the amount of JavaScript that we ship to the browser through integration of interactive components that are known as islands, integrating them within a statically rendered or a statically generated HTML page, right? And it promises us things like performance improvement, fast load speed, beautiful user experience, awesome developer experience, because that is super, super important to developers. But the question you're going to ask me now is how, right? And I promised to talk about a lot of hows. But at this point, how is never as important as why, right? We're going to have to address the why first, and that should help us address the why. The how. All right. So in order to address the why, I'm going to talk a little bit about how we used to build on the web, how we started building on the web to what we currently do these days, right? So back in the days when the web was young, right, we built multi-page applications. Pardon me. Back in the days when the web was young, we used to build multi-page application. This used the system of static site generation and server-side rendering. It means this explains the situation whereby a user requests a user requests to visit a website, well, anyway, and that sends a request to the server, and the server has some server-side languages like PHP, Python, and some other server-side languages, and that really builds the HTML and CSS and the data that we need to present the web page, and that pretty much sends the data over, and the web page is presented immediately, and you can start interacting immediately. But sometime down the line, we got bored. There was no interactivity, right? But in 1995, we got JavaScript. It was introduced, right? JavaScript came and he gave us some extra interactivity, and it still mean we had the same setup. We requested data from the server that builds the HTML and CSS we need and the data that we need to present a page. And then a little bit of JavaScript is sent. And on the client side, which is in the browser, we've got innovations like jQuery and Ajax. These are good innovations that helped us, like quickly handle JavaScript on the client side. And we had Ajax at the time to also help us say no to, all the run race, go to the server, come back, and stuff like that. It handles that for us smartly on the server, right? This was sweet. We had good stuffs then, right? And with multi-page application, it means our race to first meaningful paint, which is getting content and time to interact on the website, is always smooth. Like we get our HTML and CSS the way we need to get it immediately, and then we get our first meaningful paint immediately. Our time to interact is really fast, right? We had that then. And then we have good benefits. We have fine SEO. Start speed of the application was sweet. Quick time to interact was immediate, right? And then, but I guess we got bored. We just discovered some faults. And the faults were maybe because we're not modern enough. And maybe we also think we can do better in terms of like user experience and developer experience. And maybe the setup wasn't just, like sleek enough for the kind of web-based application we want to start building, right? So we just moved on, right? And we introduced single-page application, and that is the insertion of the meta frameworks, right? And at this point, we started to do something called client-side rendering, right? We used to do server-side rendering, but now we do client-side rendering. We needed a lot of stuff. So client-side rendering meant whenever a user requests data from the server sends a little bit of HTML and some JavaScript bundle, which can be a lot, right? And these JavaScript bundle are really required by this meta framework to do a lot of stuff, right? And this stuff are building the web page that we need to see, right? It also needs it to fetch data and paint the data for the web page. It also needs it to, like add interactivity, manage state, set up navigation, and all sort of stuff, right? With client-side rendering. So with client-side rendering, we've got like this web app, which is the same thing I built then, right? So this is my website I was performing so bad actually uses client-side rendering. So this is the boilerplate HTML it sends, just a small amount of HTML, right, to paint the page a little bit, and then it sends this lot of JavaScript. And this lot of JavaScript that you see right here is a JavaScript that it uses to build the page, add navigation, add interactivity, and all sorts, right? So moving on, it meant now that with client-side rendering, our race to first meaningful paints requires us to get a little bit of HTML, get all the JavaScript we need, parse it, and that JavaScript is then used to fetch the data that needs to be written on the page, write the page, and then we get our first meaningful paints. And after then, we can start to interact, right? So with this, we had what we needed. Modern setup finally, our response time was quick because we didn't require a lot of HTML. It comes fast. We just have to go and do the rest on the client side, right? We finally have great user experience. Finally, we can also build, the web-based application that we want to build, right? But then this brought new problems. Like we traded off some stuff. We traded off SEO. We started to ship a lot of JavaScript that ended up doing some stuffs like you get to wait for the page. Best case, you get presented with a loading spinner or a white page while the JavaScript bundle is loaded in order for us to, like paint the page. This results in bad FMP, right? It results in bad user experience for mostly low-end devices, right? But in cases where websites is that website or the application is something where the content on the website is super important, this became bad. Like we had to wait so long just to get content for just a website. This was bad, right? So for that reason, we had to find a solution to that, and we brought in SSR with single page application. Now, SSR is the server-side rendering. That's the sweet spot of multi-page application. And this meant that with this setup, SSR plus single page application with client-side rendering, that means now we get to a situation where whenever a user requests data from the server, visits a website, we get the initial HTML and CSS and data that needs to paint the page, right? But we still ship a lot of JavaScript with that. And this JavaScript is now still required by the meta frameworks that powers the single page application. And it needs this JavaScript bundle to just add interactivity to the web page. That means if there are certain components within the web page that requires JavaScript interactivity, this JavaScript bundle is a thing that goes on and add the JavaScript to the page, and it does this through a process called iteration, right? Iteration is a process whereby JavaScript is applied to a server-side rendered HTML, a server-side rendered page, right? So with this, I went on and did a new deployment of this same website that I did, which was performing badly. I implemented server-side rendering. Now, with server-side rendering, if you go to the source page, you see here that we don't get just the tiny bit of HTML we got from the basic single page application. We get the server-side rendered HTML, right, which is content for the page already, right? But the next thing we just need to do now is we just need to now iterate. So it means that we go on and get the HTML, the JavaScript that is required to sort of like iterate the page. Now, this JavaScript is also like another old JavaScript representation of the entire HTML of the same page, right? And it's required to do the iteration, right? So this setup was nice. We were able to arrive at our first meaningful paint easily because we have the HTML and CSS and the data we need to paint the page quickly, right? So we get our first meaningful paint on time, but then we still need to do a lot of like JavaScript parsing on the client in order to iterate the page, hence making the content on the page interactive. So it means that within this time, till we iterate the page fully, the components are not interactive yet. We still need to wait for them to interact, to be interactive, right? So this finally brought us some things we traded off, like the SEO that wasn't good. The first meaningful paints, we got that back, and our user experience is now finally back for, like low-end devices, right? But this still brought new problems. We were still shipping unnecessary JavaScript, right? We now had slow time to interact. I mean, I've got content on my page at this point, but I cannot interact. Why? Because I'm waiting for the page to iterate, right? So it means now that with slow time to interact, I can just have a web page with content I can interact with, but I cannot exactly interact with the web page because iteration is still going on, right? So while the JavaScript web page, while the page is getting iterated by JavaScript, I cannot interact with the components until the iteration is done, right? So in cases where interaction is important for such websites, like let's say you need to click on the button to make sales, you need to click on the button to quickly make contact that can get you business, and those buttons are not getting interactive immediately, that is really bad for UX And if you're a business, if you're on the business that sells something and you need those interactions to convert customers, that is really your conversion in danger, real time, right? So it meant that there is a problem with how we iterate, right? So in order to address this, we needed to make sure that we get new iteration approaches. So it became important at that point, and we needed to know how we hydrate our web page, because our web page just gets hydrated in such a way that the entire web page is hydrated at the same time as one component. The HTML is ready, right? The JavaScript that gets sent to the client side alongside the initially rendered HTML is required to go around each of the components, each of the nodes inside of the HTML to ask whether a certain component needs hydration. If it needs it, it gets hydrated. If it doesn't need it, it gets skipped. Any component that gets hydrated within that period doesn't become interactive until all the nodes on that web page is completely traversed, right? So until the hydration process is completed, that is when all the components or any component that requires hydration gets hydrated and becomes interactive, right? But new hydration approaches was required in order to address this situation, right? So the first of the two hydration approach, kind of similar, is progressive hydration. Now, progressive hydration kind of suggests that we should just progressively hydrate interactive components on a web page in such a way that you hydrate the first one, make sure it's interactive, then you go to the next one, make sure it's interactive, then you go to the next one, hydrate progressively, one after the other, hydrate the first, then go to the next. In that way, before the other ones are getting hydrated, the one that is right there, which is the first one, already is hydrated and it can become interactive while the others are getting hydrated. That's progressive hydration. So the second approach is partial hydration. Now, partial hydration is maybe more sweeter. I kind of like this one. It's a hydration approach that suggests that you should hydrate a certain component that is right in your face immediately, and you should only hydrate it if it's required. If we need it right now, hydrate it. If I don't need it, you don't have to. You can just leave it and do it later, right? So it's more flexible. You can hydrate it right now. You can also hydrate it depending on how a certain person says you should hydrate it, right? So this right here is the main idea behind island architecture. And it's important to state now that the sweet spot of islands architecture with islands is islands, right? So this particular interactive component that requires hydration is the thing that are called islands under islands architecture, right? So this is my website, the one I created, right? It's important to state that the only part that was interactive on the web page as a whole that we saw was just a navigation bar. And the only reason why I needed that interactivity was because whenever I reduce the size of this page to mobile, or whenever it's being viewed on a mobile device, I just need this, like this menu click icon that you can click and it should, like slide out the menu drawer and click it and close. That's the only interactivity I need. So in this case, that was my island. That was my interactive component that needs hydration on the client, right? I don't need hydration any other place on the website. That's the only place where I need hydration, right? So I've just gone on, and then what I'll do now is show you my implementation of the islands, the one I just demoed, which I said, performed really well. And as you can see, this is me going to the source of the page. And as you can see right here, this is the JavaScript. I said the JavaScript, come on. This is the HTML I need to, make up the page. Server-side rendered, it painted all the content on the page the way exactly I required it to do, making a lot of sense, right? And then if you go to the other page there, what I want you to pay attention to now is the amount of JavaScript that I just shipped here. And the JavaScript just says nav bar. So it means that JavaScript that you see right there is a JavaScript that was just required to hydrate or to just perform some setting operation that would make my navbar interactive, right? I don't have any other JavaScript that doesn't make any sense. And don't look at the client and the index. Those are just required. They would normally ship anywhere, but just tiny bit of HTML, JavaScript that are required to make this work, right? It's not one of the JavaScript that disturbs performance in any way, right? So this was just really great. My HTML comes, I've got my navbar HTML, just a navbar JavaScript that iterates the page, right? Making sense, right? Well, anyway, so if the page was iterated progressively, our journey to the first meaningful paint was super quick. Does this look familiar? This looks familiar to what we had in the multi-page application, right? So we get our HTML super fast. We get our first meaningful paint immediately, right? We're iterating progressively. And the immediate first component that needs interactivity can become interactive immediately, right? While the others get iterated progressively, like they get iterated one after the other. So it means our FMP, our first meaningful paint content just paints almost immediately because it comes from the server. And then our time to interact is just quick, right? Now, if we iterate partially, it means that we also get our server-side rendered HTML, and we get the very first component that needs iteration. We get it iterated, and it becomes interactive immediately because at that point, it's in our face. We need to have it hydrated because we need to use it immediately, right? And then the next one gets hydrated too if it's required. And if you look at these empty spaces here, are obviously going to be components that don't need the hydration at all. And at the points where we get to the next component that needs the hydration, we hydrate it. The next one we get to ones that don't need, we don't hydrate. Hydrate partially, only what is required at that point in time. Now, can I get to the sweet spot of how, or should I say, like using how we can, like do island architecture, how we can implement it, right? Implementing island architecture, we just use island architecture supported frameworks, right? And the very first one that comes to mind is Marco, right? Marco is a framework. Should I call it a framework? I think it's more like a markup, right? It's like a HTML kind of markup with extra spice. It's an open source project, like a setting framework that's created by the eBay team. It's obviously the team that powers the eBay website, right? And it presents you a markup that is, like super powered with some sugar that you can use to write your web application. And it also presents you with a setting compiler that helps you decide on which component or which parts of the application is best rendered on the server and which part requires interactivity that is also best rendered on the client that can, do some work on the client. This is what Marco helps you do, right? Great project. Like I said, it powers the eBay project. The eBay website, ebay.com, you can just check it out. I mean, come on, everybody knows ebay.com, right? So that's the first one. And the second one that comes to mind is Fresh. Fresh is a framework, a web development, a web-based, you call this thing, it's a framework. Well, anyway, don't confuse myself. It's a framework that sort of like helps you develop websites that are super performant or web applications that are super performant. It presents you the ability to write JSX, right? And it also allows you the ability to create your interactive component using Preact, which is, like one of the very great meta framework. It's considered, and it is, I don't know, a tiny, or shall I say a lightweight version of React, right? Super related to React, and it has signals, right? So it allows you the ability to write your interactive components in Preact, right? And then it allows you to use these components inside of a route or a component that is sure to be rendered on the server side statically, provided that the Preact component that you wrote is written inside of the islands folder, right? You write your interactive component inside of the islands folder, and then you export it and come use it inside of any other route or any other components that will be server-side rendered And then it will let that your prior component that you've written inside of the islands folder and you come to use inside of the routes, it will let that component only on that page or on the route or inside of any component that you use it, it will let that be the only component that requires interactivity and also requires that iteration on the client side, while every other part of the page or the web application is server rendered, right? Now, the next option, which is like the last one I've got, they say save best for last. My favorite is Astro, right? So Astro presents you an opportunity to, like write your components, your interactive components inside using any UI library that you work. I'm a React fanboy, so I really like React. So you can write your interactive components in any UI library that you like, maybe React, Vue, like UI framework, a UI library, right? It allows you the ability to write that in your preferred UI framework. Import those components that you've written in those your favorite UI library. It allows you the into a component, which is the Astro component or the Astro page, which is also written with a blend of JSX-like kind of syntax with some sweet spot of JavaScript, with some sweet spot of ability to control exactly how you iterate that component using something called the iteration. With Astro, gives you the ability, like I said, to determine how that options like say client load, client visible, client only, right? So an example of how this server render these components, but then if you get to the client side, immediately the page loads, iterate immediately. Actually, only iterate the component when the component scrolling on a certain web page. If you don't view to that certain component, if you don't scroll to that, it's hydrated, right? And it's obviously going to get server rendered before it gets that hydration, right? But then you also have, this means that don't even try to server render the client, the component in the first place. I want you to render it on the client. So this is now saying that I don't want it to be server rendered. Just render it on the component. There's other more hydration directive that Astro sort of like presents you. And the reason why I said it's my favorite is because you've got that flexibility to, like write your interactive components in any UI library that you want, right? Now, I know I promised a recipe because the title of this talk is Island Architecture, a recipe for modern web performance optimization. Yeah, so I promised a recipe, right? So recipe coming soon. So the first is do island architecture, implement island architecture, and then I promise you, your server will not be jealous. And your client can finally rest from all the client-side rendering, all the job the client-side took from the server. Your client can finally rest, and your server will not be jealous. Let your server do some work. And let your client also do some work a little bit, not the client doing some work that the server has already done with SSR, and then the client's starting to do all of that again. I mean, come on, let there be that synergy, the teamwork, let it happen, right? And the second thing is, if you do island architecture, this is hydration done right, hydration done correctly. You only, for heaven's sake, hydrate components that needs hydration. You don't hydrate stuffs that don't need it. Because like I said, with SSR and SPA, that was the best thing SPA could give us, right? SSR and SPA, you get all the HTML you need for a certain page, and you still get all the old JavaScript representation of that page to hydrate the same page again. So it's like doing two jobs. You let the server do some work, and then you still give that same job to the client to do again. Let the client rest, please. Come on. Do island architecture and let hydration be done right. So the next thing is, I promise you that if there are no interaction, you will not ship not even a single bit of JavaScript. And I have proof for this. I will show you, right? Now, the next recipe is finally, you can say bye-bye. Bye-bye to, whoa, this website is really fast on my machine, to saying hello to, wow, this is great stuff. You're loading on a small device that is slow, it's fast. You load it on a low-end device, it's fast. You load it anywhere, it just performs exactly equally. That's one of the things that island architecture can do you, right? So like I said, do island architecture. And if island architecture is something, or if islands is something you might want to, like explore with us, then I would say you should go on and check out this space, watch the space, jargons.dev. We are actually creating some cool stuff for, developers and techies generally there, right? And we're doing a lot of islands, right? You should check out that space. And cool, right? Like I said, if you want to explore some islands with us, you should check out jargons.dev. We're building something cool there, and we're implementing a lot of island architecture with Astro, right? I needed to say that because, like I said, Astro is my favorite thing of all the kind of island architecture supported frameworks, right? So I also said, I promised you proof as to no interaction, no JavaScript. So here's what I've done. I've also gone on and created a deployment of this same website that I did with the island architecture. This is a version of it where I have removed the interactivity that I said I had on the navbar, right? So there's no interactivity on the navbar right now. And I will show you how I removed it, because I said it's powered with Astro. So if you click that, you see that it's not working. And if you come to the source of the page, you see this is all the HTML that you need to paint the page, obviously, right? But then if you go to the place where there was that JavaScript that came with the navbar, you see there's no JavaScript anywhere. There's no JavaScript. So no interaction, no JavaScript. That is what island architecture gives you, right? Like I said I was going to show you how I did that. And this is exactly how I did that, right? So with island architecture on Astro, I'm able to write that navbar component with React, as you can see here, right? And then in my index page, which is like the main page of the website, which is my Astro page, I could just easily import that navbar right here and then render it in this spot and add my client directive the way I exactly want it to be hydrated. But in order for this to be hydrated correctly on the website, I stated exactly how I want it to hydrate. I want it to load exactly when the web loads. And that's how it's done. But then in order for me to say, you know what, I don't want the interaction, what I simply just did was remove this client directive to adding none. And with Astro, that's the sweet spot of Astro. If you do not add any hydration directive, you automatically get all the components rendered statically. So it means it just renders HTML and CSS and the data. It doesn't send any JavaScript. So this right here, removing just that client directive or the hydration directive, that was exactly what turned that web page to something where the interactivity is just gone and I shipped no JavaScript, right? So this web page here, you don't just, let me just not show off and show you how really sweet it was in terms of performance, right? So on this note, I say thank you very much for listening to my talk. I know that I've taken a lot of time. I think I took a lot of extra minutes, right? So my name is Olawode Lawashidebe. Once again, it's been interesting being here. You can find me on all social media, the same username at Babu Bay. And if you've got any questions, maybe you send me a DM, or you can just visit URL i.new/Ola. This will actually present you with a contact form where you can send me a message. It comes directly to my email and I will make sure to respond. And I've also prepared this repository that you can get to visit at git.new/islands. The speaker deck of this presentation and all of the resources that beautiful talk. I said that, right? Thank you very, very much. It's been a pleasure being here. And
yep. Thank you very much also. So yeah, I would agree with you about Astro. That's the first thing. And then the second thing is I don't believe that this is your talk. So this was an amazing talk. Thank you very much, Ola. So yeah,
Oh.
as people said in the comments here, most of them, you're a natural. So thank you very much. So this will be the last talk for today. And
All right, thank you. Oh,
yeah,
last
guys,
talk. Great.
yeah, the last talk. So don't forget that tomorrow still we have a full day. So yeah, from
Sure.
like today, so a day for 4 hours. We have also more talks. Hope to see everybody there. And I would like also to say that today, during your talk, we were able to pass 1,000 live viewers on all the streams, so on all the tracks.
Yay.
So this is
Yay.
also something, yeah, we didn't do before. So thank you very much, guys, and see you soon.
All right, bye.
Bye.